Nggak bisa di lock sama Dedi. Ini mami mau makan tuh biar bisa lihat.
Right. Hello, Daniel.
Hello.
Can you...
Yes, can you hear me?
Oh, yes. Let me... Yeah.
Okay, no worries. Sorry, I just got out of the bath. Yeah. Give me a moment.
Okay, I should be able to hear you better. Okay, let me turn on my video first. Right. Okay, not so clear, yeah? Right, nice to meet you, Daniel. Right.
Hello.
Hello.
Can you hear me?
It's a bit far, but I think it's okay for now.
Okay.
Yeah. My voice will not be very good. I'm recovering from COVID, so just recently.
It's fine. You're clear.
Yep. Okay. So yeah, you know, yeah, your mom contacted me, and then I suggested a trial, 1 hour.
Okay.
Trial is for both sides. I think I need to know how you study and what your needs are. And I think you should also find out the teaching style mainly. Then you should know by 1 hour whether it's going to be suitable for you or not.
Okay, sure.
Your mom did say that this is for 2 months. I think it's still important not to waste the 2 months. You know, if it is not good, then you probably could make the decision not to, to find another teacher, right? From the start,
Yeah.
right? Because, last year before the final test, right?
Mm-hmm.
Right.
The exams.
Okay. So yeah, also your mom did tell me that you went to Finding, so I looked it up a bit. Oh, it seems like a very serious place, yeah.
Yeah, it's a bit difficult to run there though, because it's a group
Right.
class
Yeah.
and everyone is from like different schools,
Yeah,
and different schools go at different paces, so it's a bit hard for a teacher to manage everyone.
correct.
So
Correct.
I think learning would be more productive and fruitful if it was one-on-one like it is now.
Right. We'll see what happens then. Now, if I'm too slow, then you should tell me, lah. Right? Even in this trial, right? Even in this trial. Okay, yeah.
What are you planning to go through today?
That is usually up to the student. So usually the syllabus of where you are, lah. I can only guess, right? You're from what school, sorry?
ACSI.
Right. Then I can only guess that you're probably near the wave section, maybe. If that is what you want to do, we do that first. Remember, it's a trial. It's for us to feel each other, right? Okay. You can talk about past topics if that's what you want. You can talk about future topics that you've never heard before. That's totally up to you. Now, what do you want?
There are a few chapters that we've been learning in school, but school just ended and we didn't get to finish them properly. Is it okay if like we go through together?
Yes. Yes. Now, usually we'll be using Jamboard. And usually the Jamboard is active on your side because my students have devices, right? I mean, my device, I lend them. But right now, we cannot do that. So this is a little bit less ideal for the student, you in this case, because I feel like the student actively asking question and showing their work is better. So I was trying to send you the device and I think I didn't get the full address, right? So instead, I'll be more active and trying to understand what you're doing. All right. Now, what do I do is I will need you to go to Jamboard. Then we can at least communicate with each other there. Have you used Jamboard before?
No.
There, it doesn't matter. You go to Google Jamboard. You have your Gmail account. That's it. You tell me when you're there. Yeah, I'll guide you a bit.
How do you spell that? Jamboard.
Yes, Jamboard, just like that.
Okay. JAM.
JM board, no spaces.
Okay, got it.
Right, you got it. And if you have a Google account, you should be signed in automatically.
Yep.
Right. Now, you're gonna there's a plus sign bottom right. You click that. You have a new Jamboard. The next thing you do is you go to the top right, and then there's a share button. You're gonna share with me, lah. Okay, I'm gonna type my Gmail account in your WhatsApp. Right, send you that.
Okay.
Now, if you manage to share with me, I'll be able to see it from here.
Yep.
All right, so let me try.
Sent. So my computer seems to be hanging a bit.
Right. So usually in this Jamboard, you can be very active and write a lot of things, but maybe even a digital pen is not available to you right now. So again, I'll be doing most of the initiative this time. Okay, so I'm going to type this as Daniel. So as you can tell, you and I can both edit this Jamboard. So let's go to the last tool. It's called a laser pointer. See, I'm laser pointing. Do you see anything in your Jamboard? Right.
Yep.
You can also laser point. I can see it almost immediately. Our connection is not bad. So let's say you use your mouse. Yeah. I'm writing something, and then just write something else.
This is using pen, right?
Yeah, you can use a pen if you have touch screen or something, but a mouse, yeah, mouse, yeah.
Okay.
Wonderful. Right, try to clear frame. Clear frame is a top left, I think.
Oh, just clear it over.
Yeah,
I do
it's
have
easier than easier than using it. Right. Okay. Now you do have your phone with you, right? So usually anytime I need to see what you guys are doing like in your own physical paper, usually we already set it up as a Zoom video lah, then I can see and screenshot. Now in this case, if I need you to screenshot your stuff, then you just screenshot to WhatsApp lah. Yeah, put it in the Jamboard.
Okay.
Why don't you just screenshot one thing that you want to show me, and then I'll put it in Jamboard and we'll start. Right, let's get all this technical stuff done.
Okay. So I'll just take a picture and send. Give me a second. Yeah. In the meantime, maybe you can share a little bit. Yeah. Why physics tuition? What's the goal here for you? I need to catch up and kind of rework on my foundation because basically this year, school did not go very well. As in the teacher did not. I don't know if he didn't teach well, but like almost the entirety of my class failed. So I think that says enough, lah. Yeah. So I've been relying mostly on tuition for my understanding, but as I said just now, it's a group tuition, so it's kind of hard to, just ask whatever I want. Yeah. And in our place, you need to ask what you want. You need to. If you're too quiet, then no. Yeah, no point. So you're sending me something, right? Okay, good. Basically, it's just, we call this chapter 10. I don't know if it's chapter 10 for you. No, this is fine. Oh, you are starting this thing. Yeah. Yeah, this is the more abstract one, right? So let's pretend we're gonna seriously study this today, lah. So let's see what we can do in 1 hour. If you hear a baby sound, that'll be my son. Yeah. Right. So let's say I pasted the picture. If you can see it already, just tell me. I need to know how good our connection is, lah. Oh, this is very slow. Oh, this seems slow. Right. Okay, yeah, it's on there. Yeah, all right. So we don't usually start from this topic because it's very, how do I say this? It's very abstract. But let me get a few things from you. You do take your HL math also, right? Yeah. Right. Were you okay with your O-level, the year 4 math back then? It must be some sort of a math thingy lah. Yeah, I got 78, I think. Right, that's the final, right? Yeah. Okay. So your differentiation and integration and kinematics should be okay for the year 4 standard. Differentiation, yes, but integration I've forgotten a bit. Good news for you. The math in physics is always lagging by around 2 to 3 years lah. You should be fine now, right? So for this particular chapter, if you can take the differential integration, just a very basic one, you'll see later, and the graphing, you are going to understand what they want much easily. Because one more time, this is very difficult to show concretely. The few topics, kinematics, dynamics, forces, a lot of things I can show you concretely in front of us. This one difficult, yeah. So we are relying on math, right? So let's get it. If you want to go to an easier topic, there's also chapter 8, which I don't really understand. It's the the black body radiation and the albedo. Yes. We can try. Why don't we try 2 things? Again, this is trial, right? Sure. So let's try this one for maybe, I don't know, maybe half an hour, and then maybe we'll switch to that one, and then you have a sentence, right? Okay, sure. Okay. Again, you must ask questions, and you must stop or ask me on whatever it is that you feel needs to be adjusted. Okay. Because this is the first time we meet, yeah. Because I don't know you. Okay, so when you talk about field, I'm going to define that informally for you. Field is almost force.
Almost. Okay.
Almost.
So I'm going to start with force. It's a very simple concept field, but it's very abstract because you cannot see it. So I'm going to define it that way. So in this case, gravitational field is almost gravitational force. Electric field is almost electric force. Electric force and gravitational force, you know, right? So for example, Fg is a rather formal way of writing gravitational force. And Fe is a rather formal way of writing electric force, right? Electrostatic force, precisely. So look at the formula. The formula should appear kind of familiar, maybe, right? So G m1 m2 over distance squared. I'm just going to write down there. Okay. This is actually exactly your mg, right? So back then, gravitational force, you know it as weight. You know it just like that. That was the basic thing. And then they expanded
gravitational constant, right?
Gravitational constant, which right now is no longer constant. That small g is what they call field. The moment you go field, you'll see the scenario later. We're not on Earth. On Earth, the g is constant because the distance between us, the guy being affected by Earth, and the center of the Earth, the center of mass of the Earth is rather constant. You jump, you shift the distance a little bit, too small. So we assume that it is constant. It was never constant in the first place. But for near Earth application, which is all our normal life, that's okay. You go outer space, then field becomes no longer constant. In fact, if you go to, you go to outer space, satellites are outer space.
So like in orbit, it wouldn't be
orbit no more. Yeah. Okay. So back then, when you mentioned orbit, it was firstly in the circular motion, but they never hint you on the fact that g is not constant. No? So now they will start. No? They will start because turns out, look at this guy. So this is us. Let's call this us, and let's call this the Earth. Look, okay. So this is us. So right now you can already see what g is. Look. G is, for some reason that you do not know, is the big constant, big G, the mass of the Earth, and 1 over d square.
Wasn't it r square?
R square. And R makes it just as an initial. Initial R is a very formal way. I would say D, because actually the distance between the two center of masses. R has a connotation in our mind, is a radius, which is totally not true. So I'll just stick to it for a while, just for you to get used to it. Some students memorize this until the end. That's not what we're trying to achieve in this half an hour. We're trying to at least understand roughly what the physicists are trying to say for now. Okay. Right? So distance. So we'll use D for don't memorize R, right? You see why I'm telling you that field is almost force, because field with another mass is now force. So there are a few implications here. Force or gravity force is a force between two mass. This is that's the simplest way of saying it. If you only have one mass, you have a field. The moment another mass appears near you, you have forces between the two masses. So one more time. Here's Earth. Let's pretend that there's only Earth in this space, right? And if there's only Earth, which is mass of Earth, I'm going to say something very simplistic. He does not experience gravity force, right? I just say something wrong, but for A-level sake, that's totally fine. I'm sorry, for IB sake, that's totally fine. So one mass, no force, no? Two mass, this is us, or us here, near the Earth. Then I will pull Earth and Earth will be pulled by me. I'm sorry, I will pull Earth and Earth will pull me. Those are the two action and reaction gravity force, right? So let me repeat that. Force of gravity between two masses, two separate masses. If you just have one mass, that mass is, quote unquote, generating a field of almost force, waiting for the other mass to appear. then it'll become force.
Ah.
So when you are interested in field, you're saying that I'm going to calculate all the field, and then I'm going to be ready for that particular mass to appear. For example, the asteroid passing Earth, what will happen to the asteroid? For example, if I put a satellite on orbit of Earth, what will happen to the satellite? It'll be very easy for me to figure out because it's almost force, right? Very short introduction. Okay, yeah? That's the intention of it, right? The intention of it. Because you can have so many masses around Earth. It can be us, it can be a rocket ship, it can be satellite, it can be asteroid, it can be the moon. If you just calculate the field of Earth, you can therefore handle all the different masses by simply inputting their mass. Finish, no? All right. So one more time, the field of the Earth depends on what? Depends on, well, the mass of the Earth. A G constant.
Yeah.
And then the distance to whatever position you're interested in. That's the position that you're going to put that.
Couldn't you say the
mass.
distance also affects in that case?
Oh, yes, it does. The field strength depends on distance. It's not a constant. So my field, I also generate a field. I have a mass. The big G is there, constant. Near me and further away from me, my field is stronger or weaker. Nobody's going to feel my field because it's weak anyway. It's a very small mass. But the field of Earth, you will feel it if you're another mass.
Okay.
Right. So that's the brief introduction to field. Let me show you the electric field. It is, so to speak, exactly the same. Then we'll go to some sort of application if it is possible. So maybe in your lecture note, you will see this also. Also, the bottom one is R squared. Also, that's the distance between two charges. Right? So look at the similarity between them. They're very similar. Right? So for a charge to experience the electrostatic force, there must be two charges attracting each other or repelling each other. If they just have one charge, he very simplistically does not experience any force. He just have field, an almost force, ready for another charge to go into his area of effect, and therefore both will experience forces.
So if it's just one, even though it's charged, they won't have any force? Any force.
Because you must understand the physics of our universe is as simple as charge, attract, or repel another charge. If it is a non-charge, then he doesn't experience any disturbance by any forces.
Okay.
Mass attracts another mass. That's it. It's just that everything has mass. So it's very difficult to say, oh, there's only a singular mass, but just imagine it. Okay. Right. All the lines and fields and directions, I'll leave it there for a while. Any questions so far?
No, actually.
All right. So a common situation is something like this, right? The first page, your first page does not tell you that. Okay, you know that force is a vector, right? I now tell you that field is also a vector. The implication is very, very simple. When I add forces, I must use my vector law. I cannot just say, here's 2 Newton, right? This is forces. Forces is something you understand. 2 Newton plus 3 Newton equals to 5 Newton. Now, you think carefully. Can I say that or not?
I mean, yeah, they add up.
No. No, you cannot say that. This happens only if they are in the same direction.
Sorry.
If they're in a different direction, see?
Then they cancel out.
Then, like that, 1 Newton. Easy to understand. If they are in a perpendicular direction, 2n plus 3n, then what happened? Then you apply your math, right?
The
something like
A square plus B square.
Yeah, square root 2 square plus 3 square root, whatever there is, that is the answer. Now, this is all I mean by forces is a vector, therefore field is a vector. In this chapter, we are interested in force, but we will always work with field. We will always work with field, and since field is almost force, we will add them up, subtract them, whatever. It behaves like a vector, just like force. That's why I keep telling you, what is field? It's just almost force. Just an almost force waiting for one more guy to appear. Yeah. So let's see that in action. Sorry, any questions so far?
No.
Right. I did tell you that this is abstract, yeah?
Still trying to wrap my head around it.
Yes, it will be. I'm pretending that you understand for now. We're gonna just fast forward a little bit, right? So here we have Earth. This is an exam question, right? Here we have Earth, and here we have Moon, right?
Yep.
And we have another mass, three masses. So that would be us, an astronaut in between Earth and Moon, right?
Okay.
We are not interested in the F between Earth and Moon. We are not. We are not. For us as an astronaut, that doesn't matter at all. That will unlikely change anyway. Nothing is going to knock Earth out of course, and nothing is going to knock Moon out of course. Let's pretend that that's true, right? So they're going to rotate within each other, and we don't care as an astronaut trying to survive in space, right? If you ever become an Elon Musk fan and he deliver on his promises, then you may be in this situation, maybe, right? So now here we are. Since we can be anywhere, and since our mass can vary because we may be carrying stuff with us, right? We cannot just exist in outer space. So we shall focus on the field instead. So what is the field affecting us? First, the field of Earth. Second, the field of Moon. And so the symbol of field is small g, which is no longer constant. Sorry to spoil that for you. Really, yeah. Now you're gonna tell me what's the formula without looking at your lecture note. Do you remember what I wrote?
G equals gravitational constant M1.
Big G. Yeah.
Big G M1 M2 over distance.
Oh, that's force. Force 2 mass. Field 1 mass. Right. So whose mass is it?
Who are we talking about? What are we
G of Earth in this case. Small
so
g of Earth.
M will be mass
M
of
of
Earth.
Simple, right? Over
radius of Earth, so R squared.
Yeah, but not the radius of Earth. Again, it's a misunderstanding. So this is a distance. The distance between who? The whatever intended mass and Earth. We'll keep it like that. Right? Okay. So if we don't know where we are, then we just keep it that way. It's totally fine. Totally fine. Keep it that way. Keep it that way.
Doesn't need to have a value.
No, it will. It will. If they ask you to calculate, but it's their job to provide you, not you.
Okay.
If they want a value, they provide the other value. You don't have to worry about that.
That's true.
Right. So, I mean, just to make it more realistic, the distance between Earth and Moon does not change. Fair, right? It does not change. Yeah. We'll call this as a we'll call this as don't call it a D. Let's call it a Y, and let's pretend that I know because I don't know. 1 second, no, 8 seconds to the moon. No, that's 8 seconds to the sun. So around 7 meter, like something like that. Okay, let's pretend that that's correct, right? Now that is not d squared. You understand? That is not d squared if our mass of interest is not Moon. The d squared will be this guy this x if the mass of interest is us. Yeah. Now this distance, what will you say? This will be 10 to the power of 7 meter minus x So if the mass of interest will be us, then this guy will be x. Now, how about G of moon? G of moon, the formula will be?
Big G mass of moon over distance squared.
Usually, it is their job to provide the mass of moon and mass of moon. Usually. Right. So what is this distance?
MCQ
Yes,
questions, right? These MCQ questions, like usually the first question, they ask you to like estimate the mass of the moon. That is 10 to the power or something.
Yeah.
How do you do those kind of questions?
You take a picture for me and then we'll do it.
Okay, let me see if I can find it. You continue first.
Yeah. So no, I'm waiting for you. The distance between the moon and the mass of interest will be?
Whatever. Oh, why? Oh, wait,
no, not why. Because when I talk about Earth and Moon, right?
10 to the power of 7 minus x.
Minus x. Okay. Okay. And then I am going to add them up. Because the mass of interest us is being affected by both the field of Earth and the field of Moon. So field Earth Moon, right? Written as this plus that. Please understand that they are vectors though. Please understand that. So if the question is nice and they put you just here, the adding will be quite simple. The G of Earth direction will be pointing to Earth and the G of Moon direction will be pointing to the Moon. Adding them is simple. Okay. Let's just say that this is 1000 and let's just say this is 500. So what is this 1000 vector plus this 500 vector? What is it?
1000 minus 500.
Very good. You must say the final direction in
terms of the direction, I guess. So it will be 500. Are we talking newtons?
Field, doesn't matter the unit, the direction right now.
Oh, so 500 units towards Earth.
Very good. I like your phrases, towards Earth, right? You don't even say left. I like that. Good. So that's it. That's for our G Earth plus G Moon. Whenever we're going to do the real calculation, we do vector. So now it depends on the question. If the question wants to put us not in line, if the question wants to do that, then we have directional issues. It must be this plus that. His job, the question maker, is to supply us with more numbers, more angles, and whatever not. Okay. But if he wants to keep it simple, he put it online, then it will in line with the Earth and Moon, then it will be simpler. Right? Now, one more question for you before we go to your MCQ, right? So here's a very common question for them to ask as an okay, if we are astronaut, find the point where we are not accelerating. Find the point or position where we are not accelerating. Now, does that question make sense?
It's like the just nice, you know what I mean? Like the point in
just nice where?
Just the like vectors cancel out.
What vector? No acceleration means?
The directional vectors, when you sum them up, is 0.
Whose vector are we talking about here? Acceleration is vector, right? Are you talking about acceleration vector?
The vector of the man with respect to Earth and the Moon.
Oh, no. Okay. So vector means something with direction. So is it the acceleration? Is it the force? Is it the field?
The field?
All three.
Oh, all three.
Why? Because when you're not accelerating, obviously your total acceleration is 0 lah. That's obvious lah. And acceleration is a vector, so it's 0 lah, right? Oh, but acceleration is always force equals to mass times acceleration. So the force vector also 0 lah. Oh, wait. If the force vector is 0, that means the field vector is also 0. because the only thing separating force and field is only a mass, us, which is a scalar number. All these three is 0. Look.
Huh.
That doesn't make sense. That makes sense or not?
Kind of, yeah. It's
Right.
not something I would have come up with myself.
It will be very useful for you. It's not something bonus. I wasn't giving you something like a special skill. You should have this for year 6. You should. Right.
Okay.
So that question can be interpreted as, you want me to talk about acceleration? Sure. Force? Sure. Field? Sure. Just judging from where the question is going, I'll go for field. So GE vector plus GM vector equals to 0 for that position. Okay. Look at what let's say I have this, and let's say they give us the mass of Earth. Let's just say that. I have big G, they also give us the mass of the moon. Let's say, look. Okay. Finally, they do give us the distance between Earth and moon. Right? So in this equation, how many unknown?
2.
No, 1. X and X.
Oh yeah, sure.
So we can solve it, is what I'm trying to say.
Yeah.
Right. So that's how we understand the question. That's one question that is a basic one to test you. Right? Any question? If not, we go to MCQ.
Yep, send the MCQ already.
Okay. Go to page 2. That would be, first. Oh goodness! Wait. Are you talking about question 1? Is it? Oh no, that's not a field question. This is
that's talking about. It was like the estimation. Yeah.
Oh right. So, during primary school, PSLE, there was an outrage like 4 years ago, I think, when they really asked the student to estimate the weight of a coin, something like that. Right.
Oh yeah.
To us, it's obvious because let's say the correct choice is C. The A, B, and D is wrong one. For example, the coin cannot be 1 kg. Let's say that's option D. Cannot be. But that's based on our prior experience. So it's a very experiential kind of math. I think that's a good question, but people usually get outraged. Some students do get outraged. Now, if you manage to not be outraged with this, can you predict the mass of a smartphone? Because you do have a smartphone.
Yeah, that's true. They're about 300 to 400 grams.
And based on that understanding, no need to be precise, you should know that the answer is, the D is 100 grams. Okay, maybe not. Yeah, maybe not. But
I wasn't sure exactly what the other units were though.
That means you don't know what's nanogram, microgram, and milligram.
Milligram, I know.
So that means question C is 1 kg, which I think you're correct, right? As in C, I think you should get rid of C, I think.
Yeah, C will be 1,000 grams,
which is cannot be we don't like those kind of questions. The nanogram, because we don't know nano, I think that's what they're testing you. Nano is 10 to the power minus 9, no? So this ends up being 1 kilogram also, you're right. And then the micro, this is weird. The
yeah, I calculated it all out and it was just like, huh?
Micro is 10 minus 6. That's also 100 grams. So let me think for a while. 1 kg. Oh, the question D is 10 grams. Question D is 10 grams. Question D is 10 grams. So A is 1 kg, C is 1 kg. You don't have to worry about that. B is 100 grams. D is 10 grams.
Oh, it's 10.
Because 1,000 grams, 1 kg, 1,000 grams divided by 100, like 10 to the minus 2. So that's 10 grams, and that's why D is wrong. Okay. So if they ask you for the order of magnitude or mass of a moon here, of course, we don't know what's the mass of a moon, but perhaps ABC will be wrong, maybe. If that's your question.
Okay.
Right. There'll be other circular motion question or field question. topic that we went through just now, which actually questions the mass of the moon, and it is possible to do that.
Okay.
Right. But when we go there, we cross the bridge then.
Okay.
Now, I give you a very brief introduction of field. Now, you can choose to talk a bit more of this topic, in which case I'll take some examples from your lecture note, or you can change topic. Just remember the purpose of this trial to have your field.
I think I'll change topic.
All right. So you send me what you want.
Okay. Give me the first few pages. Okay, that's the stuff that I'm confused about.
Yes. If you already read or studied that chapter, just focus on what you want.
I've read through it myself. But there's some stuff that I don't really understand.
Those kind of honest question is what we're looking for. That means you did your stuff already, right? You read already.
Yeah. Sorry, I think it's
send me something. Okay, so I'm just going to put it in the Jamboard.
I'll send you a few things.
Yes.
It's a whole series of pages that I just cannot understand.
Feel free to clear everything.
Okay.
So you send me
the last one.
1, 2, 3, 4. Yeah, good. Okay, so I'm just going to put stuff here first. I'll put it in separate pages. Okay, yeah, this is a bit long, but okay, you send me 5 pages, right? Did I even copy it correctly? Okay, no, let's just talk about them first. First page, at page 2 of the Jamboard. Tell me your concerns. You can use the laser pointer, might be helpful.
Let me see. Just this black body radiation.
Right. Your question is what is that? Is it
is there a simpler way to explain it, and how your questions ask about this? So how I need to know how I need to use this in answers.
Okay. Can you accept that your current body right now is radiating heat to your room, for example?
Yeah.
Okay. Can you accept that something colder than you, let's say the ice Milo that you're drinking, that ice Milo is also radiating heat?
Yeah.
Because usually you will think of the ice Milo glass as radiating cold. I mean, if you get closer without touching, you can somehow feel the cold already.
Yeah.
Right. So it's more like your heat is being absorbed by the ice Milo glass. Right. Now, it goes like this. Our 0 degree ice Milo is not 0 degree Kelvin. It is 273 something Kelvin. So that means there are other objects colder than ice Milo. In fact, we are like 273 degree higher than the possible absolute 0, right? Okay. So that's in your notes on radiation. All objects with a temperature above 0 radiate wave, this is their physics way of saying that I will release heat if I'm above 0K. It is not easy to understand it until we do some comparison, right? I'm guessing that you want to understand. If you want to just memorize, you just accept this. Okay, yeah. Now, so what the Ice Milo thing is saying is like this, right? The Ice Milo is how do I say this? We can't even see infrared, so that's another issue, right? Okay. So during COVID, we have all the beep 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 temperature lah. Beep 36.5, right? Beep 36.9. Beep 38. Oh, you're having a fever, right? Those beep beep beep, what are they detecting? They are not detecting temperature, because they are not touching you. That's the whole point.
Yeah, that's true.
Yeah. What are they detecting? They are not detecting heat. It's very difficult to detect heat without touching. You shouldn't trust that kind of result. You can don't touch me, then you tell me I'm 36.5. Wow. So what are they detecting? They are detecting the invisible thermal radiation called infrared. Do you accept that infrared is not red? Infrared is invisible. Your TV remote.
It's not the visible spectrum.
Yep. So it's called infrared because it's below red. That means it's no longer what we can see. Some other animal can see. I think cameras can see. So depending on the sensor, right? Okay. So those PPP is receiving the radiation coming from you. That means you are bright with radiation that you cannot see. Okay. So first of all, infrared is not feasible by us, a bit difficult to accept for a while. Secondly, infrared is the one that causes most of the heat transfer. Believe it or not, we emit, I think, very slight UV, very slight. Most things don't emit UV or emit very slightly. Right? Some animals do emit UV and some animal eyes can catch UV. The UV does not transfer heat efficiently. The infrared is the one that transfers heat efficiently. So during Sec 1, Sec 2, year 1, year 2, or year 7, year 9, when you learn heat transfer, you say convection, convection, radiation, right? The radiation is the one without medium. So what they mean by that radiation is the infrared radiation, the one that carries heat. So those are the two things that you have to accept because you cannot see for now. If you want some sort of proof, let's use the PP thermometer as some sort of proof. Okay, Kenya, apologies, is conceptual. Now, the black body radiation. Black body radiation is simply saying, I don't just emit infrared, I emit across the spectrum. When he say across the spectrum, you know the spectrum, the spectrum of light. So visible, infrared, UV, X-ray. Obviously, we don't emit X-ray a lot, but the point is we emit more than just infrared. That's all he meant by black body radiation.
So a black body radiator will radiate light as well?
At a lower, much lower intensity infrared. Most stuff emit mostly in the infrared region. But some stuff do emit visible light, lamps, suns, and yet some other stuff do emit UV very rarely. So black body is more like, you should think about it like this. You don't just emit one wavelength, you emit a range of wavelength. Maybe that's the easiest way to put it.
Can this be proven? So like everything radiates a little bit of everything.
Yeah.
Is that what it's saying?
But not uniformly. Not uniformly. So let's see whether, can it be proven? Well, I'm so sorry. I don't have the equipment to prove it. I don't have.
How do you prove that everything, because the biggest question for me is like light. How do you prove that everything emits light? No matter how small it may be.
When you say light means not just the visible light, just clarifying first.
Yeah, just
Okay, all right.
on console.
In modern days, let's say in modern days, yeah, I can buy an infrared sensor, which actually sends in some range. That means I cannot buy a sensor which sends everything. I can't. Our eye obviously cannot do that. Our eye can only, our eye can only what do you call it? Sense the visible light, obviously, right? So I have my eye, and then I'll buy a UV sensor, quite easy to find. I'll buy infrared sensor. Both of them sense in a range, So maybe using these three sensor, my eye, the UV sensor, and the infrared sensor, you go into a dark room with nothing else, and then you aim your scanner on the thing in the dark room. That thing doesn't seem to be emitting any visible light. That thing will most certainly emit infrared light. That's why in night, you're going to go to NS, right? You're a Singaporean, I assume.
Yeah.
So maybe during your NS duty, you will have a night scope, right? You have a night scope. Night scope, the best one is largely infrared scopes, because what else can you see in the dark? Not visible light, but the scope has a sensor that detects infrared. Now, why else can the scope see if the things out there don't emit infrared? The things out there do emit infrared. So animals more than trees, that kind of thing. Trees and animals more than the land. Am I answering your question? I'm so sorry.
Yeah, kind of. I get where you're coming from.
Right. Now look at this graph for a while. Look at this graph for a while. The graph at page 2, yeah. So page 3 of Jamboard, right? So at 6,000 K, you have a big bias around invisible UV and IR, right? That's a very high one. No? As you go down to 3,000 K, still very hot. Suddenly, everything seems to be around as high as. I mean, it's just shallow there. Now imagine the temperature of somebody like us, which is only 300 K, something 320 K, something like that. So whatever we're emitting is very little. So why is black body radiation studied? It's not for us. It's not for us. We are usually studying for super hot stuff. Because super hot stuff, very easy to see and measure. And frankly speaking, we cannot measure a star using any other method other than the radiation. So that's why the interest in radiation, at least we start from there.
Astrophysics.
Astrophysics, correct. If that's something that you will take or your class take in year 6, right? How else are you going to measure the star? You cannot measure the size. You cannot even measure the size. You can only measure its radiation and its possible gravitational shift to guess its mass, which then you guess its size. You cannot measure its size at all. Cannot. Whatever you see as captured by the camera is not the size. It's how do I explain that? If you study that, it's a ball of gas. And never mind. Yeah, you just cannot measure even the size. You cannot measure, so you have to measure something. Right. So why is this talk about in this chapter? If they're interested in the star, they would. However, I'm guessing that after a while, I don't think that's what they talk about. I don't think so. I think they're going to talk about something else in IB. Right. Now, any question for these first 2 pages first?
What's a perfect black body?
Right. So they mentioned perfect means black. When they use the code word black body, it's perfect, meaning to say we are not perfect, or rather everything around us is not perfect. By the code word black body, you know that something perfect is black. So what does it mean to be perfect? He say it's a perfect emitter and absorber, meaning to say he emits the maximum compared to somebody else with the same temperature, which is not perfect. So a black body guy, a black body thing emit this curve, and then let's say the black body temperature is 300 I put another thing which is realistic, which is not perfect. That guy at 300 will emit a similar curve, but slightly lower intensity. That's all. Why bring this up? Because studying everything else, which is imperfect, is complicated. They want to avoid the complication. Let's go to the basic theory first. There is a perfect black body radiation. Perfect black body emitter. That's it. That's the maximum, that's the ideal curve. Let's start from there. That's all he's saying. When you sit at the star, do you assume there is a black body radiator? Yes. Because we don't know otherwise. We can't even tell. It's an assumption. But it's an assumption based on a certain ideal maximum case. So that's the maximum it would be.
True, like,
cannot be true.
It's not even like how do you say it? It's not even an assumption based on science. It's just
no.
Because of nothing else.
No. They did derive the black body radiation physics-wise. That means ideally, the most ideal emitter will do this. And then he based everything else on that ideal in order to measure our, for example, there's an albedo. Yes, darling. Wow. Okay, that's my baby. For example, they talk about albedo, right? Albedo at page 3, right? So the moment they talk about albedo, they talk about reflection, correct?
Yeah.
So like a mirror, a mirror is a very high albedo stuff, right? Yeah, correct. Albedo 1, a surface that absorbs no radiation. What does that mean? That means when he receives other people's radiation, he simply bounces it back. So he's not affected by it. A mirror is 99.5% albedo, something like that.
Whoa.
Right. So what does a planet do? A planet like us reflects quite a number of heat from the sun. This matters because if not, our temperature of the planet rises even more.
Heat in the form of infrared, right?
Let's always
radiation.
Assume that at this stage, heat, radiation, infrared, because we're talking about space. We're talking about space. We're not talking about conduction and convection. Planet, sun, star, space, moon, and
but there is radiation in space. Just to clarify.
Oh, that's the only available heat
transfer.
That's the only one. There's no vacuum or vacuum.
Yeah.
If you go see the astronaut stuff, if you face the sun without the suit, your face boil, your behind freeze. The ray of the sun in outer space scorches you one side, and then the coldness of the space on the other side freezes you on the other side without the astronaut spacesuit. That's the amount of heat you're getting, something like that.
So the intensity is very high.
Very high, very high. We're being protected by our planet. We stare at the sun right now, or we just feel, it's 40 degrees, I almost die out of heat stroke. True. Don't go to space. So, albedo, black body, black body radiation, albedo 0, which doesn't exist. Albedo 1 also doesn't exist. So when talking about albedo,
possibilities.
A range between, if that makes sense to you, if I reflect, I don't absorb, right? Is that simple? If I absorb, I don't reflect. Either I receive or I bounce back. So the black body radiation, we'll forget the emitter part first. He's also a 100% absorber, right? So he'll absorb everything people give him, albedo 0. So when the nodes start to wander to albedo, because that's not what they do in A level, right? Here in IB, they do. When they wander to albedo, they now want to talk about real stuff. First black body, then albedo. And now you know.
Okay, albedo is reflector.
Albedo is a measure of reflection.
So albedo 0 would mean it's
no reflection.
Perfect absorber.
Yes, because if you don't reflect, then you absorb. That is the concept actually. That's what you need to understand.
And black body is in terms of radiation and what's the other one?
So you must see black body in two ways: how he emits and how he absorbs other people. So albedo is talking about how he absorbs other people's radiation to him.
So a black body 1 would be an albedo 0.
If there is such thing as a number black body 1, they don't give that number, not to confuse us. No? Just talk about albedo enough, something like that.
Okay.
But you're right to say you're right to say lo. So
that's
black body 100% is albedo 0%. Correct lah.
And can you therefore say an albedo 1 will be a black body 0?
Which you cannot call black body, because black body is a code name for 100%. You cannot even say black body 99%. It's just the code word for it. The code word for black body means albedo 0 or 100%. That's the rigidness of the definition.
Then how do you refer to the stuff that's like 99%, 98%?
I'll just say albedo lo. This is not a black body lo. This is just a body. The moment you don't use the code word, you assume that there's an albedo. Simple,
so albedo
right?
is just like 99% of the time they will say albedo. And then
if they want to go that
perfect.
difficult, if you want to go to that complication, which they will do usually at the end of the question. Usually lah.
Okay.
Right. So whatever is sun and solar constant, the watt over meter square will be important, but that's not what albedo is lah. I'm trying to connect albedo with black body lo for now.
Okay.
Right? The watt over meter square will be important. Something else is something else. So let me put it this way lah. The watt over meter square, let's say a black body 100% is 1,400 lah, let's say. Right? That's the amount a black body sun will emit and emit lo. So let's say a sun albedo is not 0, however, it's, I don't know, 0.05 lo. So instead of the theoretical 1,400, you will go down a little bit lo, something like that.
So you multiply by the albedo.
Yeah, that means you whatever you are, if you're not ideal, you will be slightly lower lah. Because an ideal is measured in body terms, therefore it's an ideal emitter, maximum emitter lo. So the maximum emission is determined by your temperature. That's why they make a big fuss of it, because it's very easy to handle. The moment you know a temperature of a black body, ideal thing, finish no, you know the heat emission already. You know already. Finish. It's that simple one. Tell me the temperature of the sun, 6,000 K on the surface. Okay, done. No? Put in the formula. I know the heat emission already.
Where's the formula?
There's something T to the power 4. The Stefan Boltzmann constant, blah, 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 times T to the power 4. You try to go and find that.
Okay, I see it.
I'm not seeing it here. It's somewhere lah. It's somewhere lah. Right.
Yeah,
so
it's on the page you didn't put up.
Oh yeah, there. Okay.
You didn't put up 2 on the pages. I gave 5.
Right.
Yeah.
Like that. See, if you know the T, then you know the power emission. That's why. Stefan Boltzmann law, blah, 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 links the total power radiated to the temperature. It's a very easy way of saying, I just need temperature. I need the power. I have the power already. Simple.
Could you repeat that again? Sorry.
If, for example, something like this. Let me go back to primary 5. Okay, distance, speed, time, right?
Okay.
The triangle, right? If I, oh goodness, it's 8. Right? So if I know speed, do I know distance and time?
Yeah, no.
No.
You need to.
Yeah, you need to. Yeah, correct. You need to. Yeah, it's a triangle, correct. So if I have speed, good for you. You still need 1 more lah for the other guy to be known. I don't need to know 3. Just give me 2 lo.
Okay.
Right. Stefan Boltzmann law, simpler than that. Just give me 1. The other guy I know. Give me temperature. I have the total power radiated in terms of, radiation of heat lah.
How deep? Oh, E is power radiated over.
Yeah, E is 1 for black body. The sigma is a constant. The A is the surface area lah. Okay, you have to know the surface area. So I'm simplifying things lah. Fair, right? Fair. But okay lah. You tell me it's a sun. I'll assume it's a sphere lo. Surface area no. Give me the radius lah. And then here, and then I know the power radius.
Okay.
Right. However else you want to see this law, that's the purpose law. That's the purpose. Give me temperature. I will go to power radiation. And I'll use the power radiation to calculate important stuff lah, like where I'm going to survive in the space or not. Something like that. How much power, how much wattage is received by the moon, so I can survive there. Is the global warming changing the weather pattern and therefore changing the albedo of Earth? Therefore, we're receiving more or less heat, blah, 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 those kind of stuff. What kind of solar power can I expect from my satellite up there orbiting, because there's no cable to connect? I need to have solar panel. What kind of expected power can I expect from the sun in orbit? That kind of stuff lah.
Also, there must be a lot of shielding in satellites.
But the solar panel shouldn't be. The solar panel should be as transparent as possible. Shielding wise, just to shield the electronics inside lah. For the meteorites, I'm so sorry. A hole is a hole. That's it. No shielding can. That's just human terms. That's just luck already lo. You kena lo.
Such is life.
Yeah. ISS also like that. There is no meteorite shielding as far as I can tell. You keep repairing stuff there. You keep repairing stuff. Radiation shielding, UV shielding, X-ray shielding, gamma ray shielding for human being. That's all. That's all. Right. So this is roughly where this topic is heading. You can have that kind of expectation in the question for this topic. After a while, you will notice that there isn't much variation to the question. For the field one, there is enough variation to help to cause you to study for a while, because there's a lot of marks at stake for that one. Yeah, so it's worth the study, even though it is also hard. It is not an easy one to grasp in the first place.
Okay. In your experience, will they test fields quite heavily in final years?
I'll get this very straight, yeah. They test electric field and they test gravity field. And both will have big marks. There's a long question for both of them. And yet they are both very similar. So either you whack both or you just don't do both. You don't do half-half.
So I study hard lah.
The thing about physics is, what other subject that you take? So if I may know.
I take math and business higher level.
Your HL is that, right? Okay.
Yeah.
So why do you take math, physics, and business? What's your thinking in the future?
So originally, I wanted to go to engineering.
Yeah.
But throughout the year, I realized that I'm not really excited to do physics. The more I learn about it, the more I'm like, wow, I do not want to spend my career doing this kind of things. So the business was kind of a backup, but I've been doing quite well in it. So I might go down that route, I guess, if I get the chance.
So I guess math is just part of the package.
Math is important no matter where I go. So, yeah.
Good for you to know before you go to uni. It's good. It's good. No regrets on testing things out right now. It's just that we cannot drop subjects. So we're
Yeah,
just
too
trying
late to
to
do that.
So one more year, huh? One more year.
Yep.
So for physics, for math, you do there's a large element of hard work there, as in hard work pace. Sorry, more like that. Hard work pace. If you just practice the right amount of questions and with the right amount of challenges, the exam will pay you back, because I'm guessing you're still aiming for a high mark for math, right?
Of course.
For physics, there's a limit to simply doing questions, though. So physics is different from math in terms of hard work. It's not so much about hard work. It's about every question that you practice. Does it make you understand more? If you're just memorizing more, the exam will you will not fail. That's what I'm trying to say. But you will not feel the same amount of payback as the hard work in math. You have to go to the understanding route of physics.
That's true. Yeah.
Something like that. Then your suffering is less and your understanding is more, even though your passion is not there.
I did the pure memorization route for physics this year. I failed by 1 mark lah. So, yeah.
That's actually already quite good. That's actually already quite good. I expected worse. I
expected like maybe 70 for physics.
Oh,
I thought memorization could carry me through lah, but I guess not.
It doesn't change until the end. It does not.
Yeah.
Having said that, amount of practice also, unless you specifically aim for understanding, then it suddenly becomes easy after a while.
Yeah.
So wherever you choose to study or however you choose to study, try to gain the understanding, and then you'll be a happier person.
Yeah.
All right. So I do have to attend to another A-level student very soon. So is the trial giving you some feel?
Okay.
Right.
Yeah.
So if the trial is giving you some feel, why don't you discuss a bit with your mom, see whether you want to continue or not these 2 months. And then if you do continue, then I will send you the devices.
Okay. Will there be notes given as well? Or just a question?
More notes doesn't seem to help, or rather more like this. If you already have enough on your plate trying to understand your own notes and your own question, it is enough to understand them. And then it is enough to start doing the questions they give you. And then I might add more questions to it after those steps are accomplished.
I don't really have any worksheets regarding these chapters though.
That one I can solve.
Yeah,
but the notes will stick to your...
but I got nothing to practice.
Which is not gonna, that's just, but that's just the same with math. That's about this. So the questions can supply. I'm not a fan of supplying notes. It's best to explain your notes.
Okay.
Right. Why make you read more? No, it doesn't accomplish much. I don't think so.
Okay.
Okay, so you want to discuss with your mom first, and then you guys can contact me using WhatsApp, and then I'll tell you more details. Okay.
Okay.
All right.
Will you be free at this timing in the future, or?
All right. So here's now the details. So I'll tell you this since the student is not here yet. So, holiday does have flexibility, I guess I must say, But usually I keep most of my tuition at night, which is like around here. It's earlier and it's okay. But I usually give most of my students 3 hours per week, and it's not 3 hours straight. It's probably not good, even in holiday. So most students take something like this, 1.5 hours, 45. That usually works out well to most people in school days. We're not talking about school days, so just giving you an idea. Some students take 1 hour, 1 hour, 1 hour, split into 3 days. So now come holiday. So some students prefer that because I can give them more work during holiday. So they just split their stuff. I meet them 3 times a day, 3 times a week, right? or they just split to 2 days, so 1.5, 1.5, something like that. If that makes sense to you.
Yeah, that makes sense.
Right. So 3 hours of physics, forget about it. Right. Forget about it. You don't benefit anything from it. 2 hours at your stage, maybe a little bit too little. So that's just, most of my students are usually at that stage. So 3 hours seems to fit fine, but you got to split it to at least 2 days.
Okay.
Yeah. So you think about it like that. Okay. If your holiday is not very busy, then I can give you more practices, and then we discuss, and then we do a little bit of exam training, right?
Of course, I'm down to continue. You seem like quite a good teacher that I can learn from. But there are some complications now because it's the holidays, as you said, and I think there's a period I'll be overseas for about 2 weeks.
That seems
December
fine. Family
holidays.
trip, right?
Yeah, family trip.
Yeah, it's quite normal, right? It's just how we look. If we are continuing, then the first session should be talking about our plan. What's our plan? What do we do? What we're trying to accomplish? What do you want to see in January? It's a totally different environment compared to school days. School days, your energy is divided. Holiday, your energy is better, even though you should go for holiday. Totally support that. Please go to holiday. Please go. It might be your last holiday before year 6, right? Maybe, who knows?
Yeah.
But we're gonna make use of this high energy time because you can think clearer. Right? So if you're going through it, then our first session should be our plan. Then we talk in detail first, then you have some idea. Right? Then the days become less important. Then if you have a plan already, then we just fit our tuition accordingly.
Okay, that works for me.
Yeah. So the tuition is not the most important thing, right? Your work and your progress will be more important. Then in tuition, you'll benefit more because you've done your own blah, 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 blah. Something like that.
Yeah.
That's the idea, at least. Okay, something like that.
Sure.
So sorry, are you you can make a sorry, I'm not very clear. Do you want to make a decision later, or you can?
Yeah,
you can. Yeah.
I'll of course have to discuss with my mother.
Yes.
I'll let her know that I'm in favor of this.
Yeah, let her ask questions. You guys talk first. Okay.
Of course. Yep.
Okay. Right. We'll communicate using WhatsApp.
Yep. Sure.
Right. See you.
Okay. Thank you.
Bye.
Bye. Ya, ikut apa? Ini di luar.
Dennis coming. Sekarang semua yakin nggak kalau gitu? Habis itu 8.30 aja. Jadi bentar lagi. You know, teacher. Mm. Right. Sorry, Anish, I wasn't wearing my headset. Can you hear me? Anish, can you hear me? Anish, can you hear me? Ines, can you hear me?
Hello, can you hear me now?
Yes, I can hear you now.
Okay.
Okay, good. As per requested, do start with the video.
Yeah.
And then we'll go to the math stuff. Wonderful. I can see your video.
Yeah.
How about the right? Let's revise our mini exam simulation first.
Okay. I
Did
did
you
it
do it morning slot or slightly lunch slot?
slightly up, I'll be honest.
It's okay. Well, we move slowly. What time? Tell me the time.
Like 10:30.
10:30. Still a progress compared to yesterday, right?
Yeah.
10 15 minutes, yeah?
Yeah.
All right. So how is it? Show me lah.
Okay. Wait. Let me find it.
Right. Oh, yeah. It's quite clear. Okay, I can see. Right. So if you check the answer key, I don't have the answer key, right? I think part 1 would be correct, lah. Right. So that's an easy 2 marks, I suppose. Yeah. Just curious on in the start, without calculation, do you know the number of fruit flies at the start?
What?
The number of fruit flies at the start. Without doing any calculation. Can you tell?
Yeah.
What?
Without any calculations, no.
Without. Oh, can. It's 12. It's a guy in front.
Is it? Okay.
Why? I'm not asking you to memorize. No. I'm not asking you to memorize. At the start, t is equal to 0. Really.
Because t is the only one that affects.
T equals to 0. So 3 to the power of 0 is?
1.
So 12.
Okay.
That guy is the start. And I am impressing upon you on that because, for example, at the next question, right? Page 5 of the Jamboard, right?
Yeah.
What is the starting price of car? Too long, too long.
Wait, one second. I'm on the wrong Jamboard.
Oh, right.
Okay.
Right.
Okay, I'm in the Jamboard now. Which page?
Page 5. The next question, right?
Yeah.
Right. The starting price of the car is?
It's 8,500.
Yeah, because t equals to 0. That's 1, 8,500, right? Look at the next equation, Joseph savings lah, S400T plus 2,000. Slightly different equation. What's the starting saving?
He started off with 2,000.
Yes, that's why yesterday when you say he saves 2,400 per month, I was,
Yeah.
How much did he save per month? 400. Wonderful. You got it. You got that one, Mark. Got it. I'm happy. I'm happy. Really happy. You're reading. Okay, back to the fruit fly lah. So for 2 marks, fruit fly, first question, easy peasy. The maximum capacity is 972 and you go through the testing route lah. So you are testing 6, 10, 8. 8 sounds very close, something like that. Yeah.
Yeah.
You tested 9. Okay, I feel that you should be testing 8 and 7. If you want your answer to be accepted, you should test. Oh, no. Oh, no. You're correct. You tested 8 and 9. No, you're correct.
Yeah.
You're absolutely correct. And your answer is?
8.
Approximate number of days. Oh, no. The answer should be, I think in this case, I think it's 9. It's 8 point something. Let's agree on that first.
Yeah.
So at 8 days, it has not reached the maximum. That's my so you should say 9, meaning the middle of 9, or as before the day 9 ends, something like that. Yeah. Probably not 8 probably not 8. So this is more like how to answer properly that's all. Okay. I appreciate your guess and check. It doesn't look so long also, right? It doesn't look so long. Would you like to know the other method?
Yeah.
Okay. Now, the other method is very simple. Look at the equation. You're going to write down. Look at the equation. It's P equals to 12, 3, blah, 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 T. How many variable?
2.
One is P, one is T. Obviously, you cannot solve, right?
Yeah.
Now, who say if we have 972, isn't 972 one of the variable? Who is it? 972.
No, it's not.
I know that the maximum capacity of container is not equal to the English, the population of the fruit fly lah. I know. However, the sentence asks you find the approximate number of days until the container reach its maximum capacity. So maximum capacity means the population of the fruit fly is?
Lesser than 972.
Or let's say 972 first lah. Let's say first. Okay?
Yeah.
So 972 is one of the variable in this case lah.
Yeah.
Who is it?
It is P.
It's T, small t?
No,
P.
P.
P. Okay. Please write that down. Please write that down and then solve it. You have enough skill to solve it, I'm very sure.
Oh, okay. That does make sense.
All right. Please do that. Okay. It's a good comparison. Doesn't mean the answer is correct. I'll assume that your answer is correct currently. Doesn't mean the answer is wrong. I'm sorry. Your answer seems to be correct, but try this way lah.
How do I progress from here?
Let me give you a hint. You want the T, right?
Yeah.
Drop the T. Drop it down. It's above. It's at the power section right now. Drop it. How do you drop it? By the way, the left-hand side, why is it 972T? That part I don't get. Is it because of P bracket T that you write it down? Is it because of that?
Sorry?
Why is there a T on the left-hand side?
Oh, yeah.
Right. Even though it's P bracket T, it doesn't mean that there's a T there, right? If it's confusing, apologies for that first. Right. Or you can do this, or you can do what you just did, which is wonderful. You can do this, and then you have an answer, which the answer will be ding, 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 ding.
8.03.
Suitable to your guess and check, right? Very suitable.
Yeah.
Right. Right. I'm being particular here because this is a log skill, so I want you to be able to do it. Of course, you can convert it into this skill, right?
Yeah.
Okay. This will happen again, yeah, in the next question. It's very predictable one. Okay. Any question for 1, 2, 3? For B12?
No.
All right. How about question 5?
Oh, question 5 I wasn't able to do.
Show me. You did something, right? So what did
I was doing? I was just doing
ln x equals to p, x is equal to e to the power of p. I agree with you, lah. So I agree with you. But since you know that x is equals to e to the power of p, why did x squared suddenly become p squared? That is the part that I don't understand. Oh, it is EP square. Okay, it's E. Oh, okay. I think you Canada in this. I think you're off to a good start. So I'll show you 2 methods. First, I'll continue from your method here first.
Okay.
Looking at the Jamboard page
4.
4. Yeah. So there's an ln here, right? Correct?
Yeah.
I think this one's fine. I think this one is fine. And I think this one is fine. Now you're in this lah. So EP square, right? Do you understand that this is E to P?
Yeah.
All right. Then EQ half is equals to E.
E Q by 2.
Yeah, alright, that's half Q, right? And then the last guy?
It will be E3R.
Right. Now there's always ln at the bottom side, but now it's already transformed to something maybe more palatable. So 2p times E half Q over E3R lah. Can't you simplify this? In this first
Yeah.
Yeah, okay, then simplify the guy inside, and then I think you have your final answer.
Do I? Oh, I do.
Yes, please try. Don't forget the ln also. Yeah, divide becomes. Oh, that's just wrong. That's just wrong. Look, The division, yeah. The division is outside, cannot be the division inside the power there. So in this case, minus lah. Yeah. Bracket, please. Bracket. That's not power, right? That's just ln bracket e something, right? Okay. That is simplifiable. Where's your basic logarithm skill? Right, you can check your answer key.
I don't know how to.
You don't? The paper does not have an answer key.
I don't remember what paper this was from. I can check.
Oh, goodness me. We should write it down now. 2019?
Oh,
Either paper
speaking of
1 or
which,
paper 2.
I have sent you the drive with, I don't know if, have you checked the email?
No. Okay, I'll check the email. But please, you look at the answer key. I should be looking at.
No answer key for 2019.
No answer key. Then let it be for now. Right? I'll declare it correct first. Okay.
Yeah.
Okay, moving on to the next question.
Now, before that, can you just check if you are able to open the drive that I've sent you?
Okay, I'm still trying to open the email. Yeah, okay, now I can. Send me here. You share with me 2008-2020 test paper, is it?
Yeah.
Try to open that. Yes, it seems like I can. So I should be going for math, is it?
You can check anything you want.
Math 2019.
Of course, you told me to remind you not to share this with anyone, so yeah.
Don't share. Yeah, there is no answer key. All right, we'll make do. Now, thanks for sharing. Now let's go to the next question. Okay, so 3A is 400, you know why, yeah? Right, then using your graphic display calculator. So your GDC, okay, please. I did say to you that this must use GDC. The reason will be clear later. Now, still no idea?
Yeah.
Right.
I tried a lot of stuff, but I couldn't.
Right. So you notice that P is the price of the car, right? Right. So that's the iPhone you're chasing after. And let's say you're saving from it, there will be your S. Now, when can you buy your iPhone?
Once my F reaches or accessible.
Right. To keep it simple, we just equate first. So P equals to S. We'll start from there. No need to say it's bigger. Of course, that's true, but no need to say that first. Just equal is fine. Okay?
Add an inequality then.
I'm so sorry.
If you could add an inequality, then it will work.
I'm sorry. Your voice is not so good. How come?
Inequality.
No, you don't have to go that complicated route. Just say equal is fine. Of course, bigger is also fine. The moment you have equal and then you have the time, right? The time is in month, right? Then you can declare that bigger than that month. You can declare the one bigger below. No need to be at the start. There is no bonus. There is no bonus mark or bonus logic there. Equal is fine. Now, P equals to S, right? Now, no, you still don't know how to use the GDC, right? P equals to S, correct?
Yeah.
If you still don't know how to use the GDC, then like this. Plot P together with S.
Graph.
Plot P, yes, graph, correct. A graph is so powerful, it'll give you everything you want. It'll give you the equal, it'll give you the bigger, it'll also give you the smaller. In this case, it should be x, right?
Yeah.
So instead of writing equals to t, why don't we just say equals to x? Replace the t with x, that will be easier, right? No need to go to 3. Just x-axis is enough. Right, so power of x. Again, go to the function. So 0.95 to the power of x. If not mistaken, you haven't done that because I cannot see very clearly. So yeah.
Is the video okay?
Yeah, it's just very small. So where's your function? Because I don't see any graph here. That means something is wrong.
Oh, it's not so.
Okay, now I cannot see because it's too high. Sorry, yeah. I go down. Yeah, go down. Okay, yeah, 1000, 0.95 to the power of x. Yeah, this should be enough. Okay, where's the graph? Let's go find the graph. Maybe zoom out a bit. Oh yeah, because you're supposed to see 850 lah. You're supposed to see 8,500. That's why you don't see anything. So 400x plus 2000. And then let's see both graphs lah. Right, so the graph currently doesn't make sense. Let's change our view.
I can't.
You should be able to change your view. Let's go to view somehow view. Window or zoom maybe. Maybe zoom out, I guess. Zoom out maybe. Maybe it's good. Much better. So they do it automatically for you. So you have your first graph, which decreases, and you have your second graph, which is increasing. Right. To satisfy your need, you can find the equal, and then you can find the bigger also. Right. Okay. Yeah, intersection. Yeah, there you go. Go for intersection. Yeah.
It's an infinity.
Intersection is not an infinity. You can see it in front of you. The intersection is not an infinity.
It is. You can see.
Yeah, this is not making any sense, right? Sorry. Move up, please. Move up. Sorry. So I can see it's very small. It's very small. Could you? Yeah, pretty close. Sorry. So the x where that happened is 8.64, right? That is not infinity. The y is 5,460. That's how we read it.
Oh.
That's not infinity. That's just 10 to the power 3. So we have 8.64 and 5,460. What does those numbers mean?
8.64 is what it matters.
All right. And what is 5,460 then?
The money he makes in the.
Which is also not the money he makes. He saves. Yeah. Which is also. Which also happens to be the
P.
Yeah, the price of iPhone or car having dropped already. Right. And this is how you get your 2 marks, right? So could you answer part B then?
Yeah. That's the answer.
The answer is?
8.64, so 9.
9, very good. If you answer 9, you're correct. No? If you don't answer 9, then you're missing 1 mark. Now, do this manually so that we know why we must use GDC. Because
actually, some 0, not 1. Because there's a highlighted complete. So
I'm sorry, what?
If I give 8 instead of 9, it will give you 0.
Your audio is bad. It's not clear at all.
Sorry. Is it okay now?
Very small. Can it be made clearer?
What's going on?
Is it me? Sorry, is it my problem? So let me check. Is it my problem? Right. Okay, try again.
Hello, can you hear me?
It was my problem. So sorry. Right, okay. Try again.
Yeah, so what I was saying is that because they bolded complete, it's your fault if you write 8 instead of 9. So if you write 8 for 3B, then you get 0, not 1, no matter what.
Okay, let me think. Yeah, because you don't also sketch the GDC, ma. I guess so. All right. So maybe if you write 8 equals t equals to 8.64 and then becomes 8, then maybe you get 1 more. I don't know. But of course, avoid that. Of course, avoid.
Yeah.
Now we're going to discuss why manual doesn't work. Manual work. Okay. So do manual work, please. P equals to S, right? So do write it down. In case in exam, they don't tell you to use GDC, you have to see the signs. You have to see what's written in the wall. Oh, goodness me, this thing cannot solve 1. I must use GDC even though they don't tell me. So they might not always tell you. P equals to S, and we write P equals to S, then what is the purpose of writing this? Because, look at that. Then you only have 1 unknown to solve, right?
Yeah.
Looking bright, right? Okay, our future is looking bright at this point. Oh, 1 unknown, I can solve this. Now, why can't we solve this? Is the question I'm posing you. So please think about it for a while. Now, do something that you think is useful. That's how you show whether it is doable or not. If it looks doable, then do something. This is important for everybody in year 6. They need to know when must do manual, when cannot do manual. So can we do something or not?
We can simplify.
All right, that's right. Simplify, always good. Oh, it looks good to me. Yeah, I like it. I like that. Good. I guess we cannot simplify further, I guess, but we can try. Okay, right.
Yeah.
Isn't there anything else that we can do?
No.
Why not?
Because the power. We don't have any other powers.
Right, there's a power t, right? The issue is the power t, and then there's a t at the bottom. Now, to long story short, if you want to find t, both those t must combine to 1. Correct?
Yeah.
That's how we solve for t. Those 2 t cannot be 2. I must put them together and squish them. There is no known method in all this universe and mathematical professors to combine the t that exists at the bottom and at the top.
Yeah.
Nobody can do it. I'm not talking about you cannot. I'm not talking about we cannot. I'm talking about nobody can.
Okay.
If you see this in exam, what do?
I do graph.
By GDC, you plot graph, you answer. That's it.
Yeah.
Okay, that's it. And what is the sign? What is the sign of you knowing, oh, this must be GDC 1 lah. Again?
Seeing the power.
The power contains?
The unknown.
The unknown, but in the bottom, there's also the unknown. You're supposed to squish them together. We can't.
Yeah.
Okay, we cannot combine, right? Okay, so that's 3A and 3B. Okay, how about 3C? You get something because you said that you can do this.
I did.
You did target 3 marks. Oh, where is it? Oh, there you go. Okay, where is it? Going up. All right. Okay. So you 2 months after he started saving. Okay. So obviously you find the saving, right? And then you find the price, and then you just minus, and then you round them up, and yeah, I mean, yeah, you're right. That's it. In this case, I think you read the question very properly, of course.
Yeah.
Okay. What do you think so far of this topic?
Not bad. I enjoyed so far.
Right. let's go find more, right? Let's go find more, and then let's add more topics to your mini exam. Now, what do you think about such mini exam training so far?
It's good. It's effective.
Right. So let's give it a try. More consistency matters more, and try to shift it slowly to the 9 a.m. region, right? Slowly, right? Because as we increase the time, maybe to 30 minutes, 45 minutes, you want to kind of stay within the 8 to 10, right? Try to stay there, right? Okay. Okay, so same thing. We're going to do the same thing as yesterday. You're going to collect the question, put it in, right? Before you do that, do you have any interest in adding more topics into your exam training? Just one or two more is fine.
What do you mean by topics?
So let's call this the questions that we did are the 3 questions, right? From paper 1, paper 2. These are INDIS and log, correct? That's the package. Look. We're going to maintain practicing INDIS and log until you are very good, right? You're heading there, you're progressing day by day. Would you like to add another package? Trigo, for example.
Can I talk to my dad first about this? Because I'm also doing I'm doing math as well, like outside of tuition. Because I wanted to do like year 4 with you and year 3 outside, but I guess we can do year 3 doing tuition as well.
No. We're going to do year 4. We're going to do year 4.
Okay.
But we put year 3 in with the assumption that we take, after a while, we just did this for twice, right? After a while, this is going to be a very fast moving thing. You know what's going on. We discuss very quickly after a while. You notice that today is shorter discussion than yesterday?
Yeah.
Right. So when you do it, you gain more, you ask more. After a while, you ask nothing else. When we discuss the question, after a while, your reading is so good in this topic, you don't have to discuss so much. So the tuition time can be used for year 4. Right? I'm proposing Trigo because either way, we need Trigo sooner or later. I think soon in year 4, in year 4 topics. We need it anyway.
Okay.
Right. Okay. So you can add today or you can add tomorrow. Would you like to add some topics today, or we'll just stick on logarithm and INDIS for now?
Logarithms for now.
Right. Okay, logarithm INDIS. Now go quickly, find the question, put in the Jamboard, we discuss, and then we go to physics.
But it's okay if you find, because I'm eating. Sorry.
No, I want you to find. Okay. But you can find later. You can find later. Okay?
Yeah.
Now, do it though. Do it. Yeah. Physics then. Right. Oh, no. You're talking about chemistry, right? You're talking about chemistry. So we can talk about physics, we can talk about chemistry, we can talk about both for now. Okay? I don't think I should be talking new topics in math right now, right? So would you like to talk about your chemistry first?
I'm okay either.
Right. So chemistry first. How's your reading? You tell me. Ask questions based on your reading first.
Okay, let me open it first.
And share your screen, yeah?
I didn't manage to read all 58 slides. I read about half.
58 slides for oxidation.
Everyone is like 60 plus slides, I think. But there's not much content per slide.
Okay, show me what you have read then.
But by the way, you can also access this.
No. We need to read it together. Okay. We need to read it together. Share screen, please.
There you go.
All right. Okay, so you open that stuff and then you tell me what you read and then you ask the questions.
Just I read about until 20 or so.
Oh, okay.
I don't have that many questions. I don't understand this.
So think about this carefully. This is the most important thing. If you don't understand this, then you don't understand, right? So let's talk about reduction first, easier lah.
Okay.
A reduction can only happen if you gain electron or you lose electron.
Okay.
Oh, he defined it as loss of oxygen. Goodness me. Let's go up a bit. Sorry, let's go up a bit. Oh, goodness me. Why do this kind of thing? Why? Okay, go up, go up, go up, go up, go up. Go up. No, yeah, go up. Yeah, to the, okay, there, stop. Have you read until not loses oxygen, not gain hydrogen, but until gain electron and lose electron? Have you read until that?
I mean, yeah, it's on the slide. Yeah, I read until.
No, I don't mean here. I mean below lah, below. You have had more slides talking about gaining electron lah.
I think I read about hydrogen. I don't know.
Okay, let's go down, and then we'll go back to your question, right? So redox reaction, gain oxygen, lost oxygen.
Yeah.
Now hydrogen, right? So let's see lah. So lost hydrogen, gain hydrogen. Okay, all right, sure.
Answer all this. I don't understand why this happens though.
Sorry. So let me understand your question. You don't understand the motivation behind them doing this, or I don't mean the teacher. I mean hydrogen and chlorine becoming H2L. You don't understand their motivation, or I
don't understand the whole point of oxidation and reduction. Why does this happen?
Very good. While you're eating, look at your Jamboard. That is a very important question. Jamboard page 6. Yeah. I'll use something else totally different. I think your lecture note haven't contained this lah. Balance it for me, please.
You can't.
You can. Goodness me, don't forget your skills. Goodness me. You're almost 70-mark chemistry student. Balance this out.
It'll be 2, 1, 2.
Good. 2, 1, 2. This, in practical life, is as simple as hydrogen gas being dangerous lah. Hydrogen gas you release to the air. You got some spark low, boom, explosion happens lah. Hydrogen burns with oxygen in a very explosive way. Your lab says pop, correct? To test hydrogen gas is pop. That, in a larger scale, is a very dangerous way to test hydrogen. You shouldn't taste hydrogen by bringing fire to it. If the hydrogen is enough, we explode. I think I told you this before lah.
Yeah, oxygen also, right? Oxygen is flammable.
No, oxygen does not explode. Oxygen just burn, no?
Yeah.
But oxygen is everywhere, right? So it's okay. Hydrogen is not everywhere. The moment it is somewhere, there's an explosion hazard. The explosion can be bad. So the way you test hydrogen in the lab is very unsafe unless you do it for a small quantity. I still don't know why they test it that way, because maybe it's just a small quantity. But they don't teach you that hydrogen plus fire is very dangerous. It's very weird to me the way they test hydrogen. Right? So remember, the small pop is an explosion. The explosion extinguishes whatever fire is there. If you have a 1 gallon of hydrogen, it's not a pop, it's a boom. Right? Now, so here go, the boom produces water, right? That's all, right? The harm comes from the explosion. The water itself is not harmful. Now, same question as you say. So why do hydrogen bother to explode with oxygen? Right? Why bother? I'll put it another way. Why don't do the reverse? Does the reverse happen?
Not really.
Based on our experience.
Yeah.
There is no proper theory to account for this, but we know that this can we call this automatically happen? The first guy?
Yeah.
And the second guy does not automatically happen.
Yeah,
So in the chapter, let's look at the content, the table of content. I'll show you the chapter where the second reaction happened. Look at all the list of the slides.
Oh.
So you could look at the drive. Look at the drive. Electrolysis. Chapter 15. We are close. At chapter 15, the second guy happened.
I
right?
see.
So just saying that. Now, if you understand this, it will be good for you. So electrolysis, whatever that means, go back to the Jamboard, requires electricity. So the second guy requires electricity, which is therefore an input of power. I need to give them power, a lot of power, so that water can split back to hydrogen and oxygen. This is splitting water. Okay?
Yeah.
But do I need to give the first reaction an incentive to react? No. Fire is not an incentive. It's just a very small trigger. Small one. Everything explodes. That's called a trigger, not an incentive, not a power, not an input. In fact, they give you a lot of output in the form of heat. Right? So the first guy gives you heat. The second guy requires not heat, but requires power. Well, heat is power, right? I'll call it energy, sorry. I shouldn't be doing that. So there's a very big difference between first guy and second guy, right? In terms of energy.
Yeah.
So that's the first indication that the first guy is going to be easy to do because he is very willing to do it. As a result, he gives you energy. I'll give you money so that I can do it. The second guy, you give him money so that he'll do it. The first guy is called willing, very willing. The second guy is called unwilling. Now, let's go to Sec 3 to discuss why. It's very simple. What am I drawing here? What am I drawing?
Covalent bond.
Yep. So here's oxygen, right? Here's oxygen. So I should be drawing dot, dot, cross, cross, right? Then dot, 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 cross, 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 right? So H, dot, cross, something like that. Okay?
Yeah.
Then I have water, right? I have water. So H, so this is dot, cross. Now the answer lies here. That this bond and this bond is less preferable to them. And this bond is more preferable to them. So one more time. Huh? H and H bond, if they don't have any other alternative, then they'll stick with it. Same thing with OO bond. But the moment they have an alternative, this is not a bond between H and H, right? Not between O and O. This is H and O, H and O. It's a different bond. Let me put it very clearly. There are there are two HH bond here, right? And there are one double O bond here, correct? And then here you have two OH bond and another two OH bond, correct? There you go. It's a very different bond situation after the reaction. Yeah. So do you know from Sec 3 why this bond and this bond, they don't like it. They're just stuck with it. And this bond, they like it. They prefer to stick with that new bond. Do you know why?
Because, no, I don't know.
Right. So I'm checking with you whether you learned this in Sec 3 or not, because I'm not very certain, right? Electronegativity, have you heard that?
Electro what?
Oh dear. Okay.
No, maybe I didn't. What do you say?
So I'm going to say a very formal word, and then I'm going to define it easily.
Okay.
Electronegativity. Electronegativity is greediness to other people's electron. Greediness. Greediness to other people's electron. What's electronegativity?
Greediness to other people's electrons.
Not their electron. Everybody has their own electron, correct?
Uh-huh.
But you can be greedy to other atoms' electron. Right? So now I will tell you right from the start that oxygen is the second greediest for other people's electron. That is how it is created. That's how it is. That there is no better explanation than that for now. Oxygen is very greedy. Okay. Hydrogen is not. Remember, oxygen is number 2. Second in greediness. Who is number 1? Somebody called F. We don't talk much about F. F is a very dangerous substance, but also very difficult to react. We don't talk about F in O-level, in year 4 and year 6 chemistry. We don't.
F is fluorine.
Fluorine, which again, we don't talk about it much. It's a very dangerous substance and you won't see it in your lab. It's very dangerous. Okay. Oxygen, therefore, even though second in rank, becomes practically the first and foremost greediest guy that we talk about. The oxygen that we breathe in, that we need for life, every day, every breath, is a very greedy thing for other people's electrons. So far, so good? Okay?
Yeah.
Now, tell me, in terms of greediness, this guy is greedy for his electron, right? This guy is greedy for his electron. Same thing, what? Right? You see that? This guy belongs to him originally, but covalent bond is sharing, so he is supposed to share this with him, but he is very greedy for this guy. He is very greedy for the guy. Same thing, this guy is very greedy for this electron, which does not belong to him originally, right? They are both equal greediness. They pull very strongly because they are very greedy. What happened to this 4 shared electron being pulled by 2 greedy oxygen? What happened to those 4 shared electrons? They are shared equally because they're both equally greedy. Let's say I'm a greedy person, okay? I'm greedy for your... Do you have an iPhone?
No, I use an Android.
Android, okay. Let's say you buy an iPhone. So I'm greedy for your iPhone. I want to grab it, correct? Because I'm greedy and I'm jealous, right? For other people's phone. Even though I have an iPhone, it's an iPhone SE. That must be why. I only have iPhone SE. I'm greedy for your iPhone 13, okay? Okay. But you're also greedy to my iPhone because you buy the big iPhone, but you want the small one to complement you. So I pull your phone because that's yours though. So you're gonna maintain You're gonna maintain your phone. At the same time, you're gonna pull my phone and I'm gonna maintain it. What happened to that 2 phone in the middle?
They get pulled.
Yeah, they get pulled. They don't get damaged. It's okay. We're not gonna do that, right? We're greedy, but we're not stupid, right? And then we'll just end up with a sort of compromise. I'm greedy. You're greedy. So we say, okay lah. I'm as strong as you, I'm as greedy as you, so we half low. In the end, it's half low, even though we are both same greedy, same strength, like that. Okay?
Yeah.
In terms of hydrogen, the electronegativity of hydrogen, the greediness of hydrogen to other people's electron is not so much. They are chill about it. They share electron and they are being chill about it. So they share without having the urge to pull very strongly. The end result still the same. They share half because it's hydrogen with hydrogen, correct? That is totally not the picture once you enter H2O. You now have oxygen sharing with hydrogen. Oxygen sharing with hydrogen. You now have that. Guess what happened when a greedy person shares with a non-greedy person?
The greedy person takes everything.
Yeah, in this case, almost everything, almost. So we'll call it 99% and 1%. It is practically like that. It is practically like that. So I'm going to go do some numbers here. Remember hydrogen with hydrogen, 50-50, right?
Yeah.
Oxygen, 50-50. Oxygen and hydrogen, let's say 99%, 1%, 1%, okay? Because of the electronegativity, the greediness, the sharing is not equal. It's not equal sharing, it's unequal sharing. So that's why oxidation number, the one that you study, right? Oxidation number of these two guys is 0 and 0. What does 0 represent? 0 represent their initial stage. Hey, I'm sharing one from you, but you're sharing one with me. It's 50-50. We are just like the initial stage, 0, 0. Oxygen also 0, 0. Okay, 0, 0 oxidation stage.
Yeah.
In H2O, not at all. The oxygen is -2. The hydrogen is +1. Please understand -2 as having 2 more electrons, not having less electron. You understand?
Yeah.
Oh, goodness me, I didn't. Kyoko, no, Kyoko, that was my mistake. I didn't see you. I'm so sorry. I'm so sorry. I didn't see you. Yeah. Right. I have something for you. Yeah. No, Kyoko, sorry. I have something for you. Right. Okay. So I'm asking you to stop the screen sharing first. Finish. Right. Just nice. I end my explanation on oxidation state there. Why did the oxygen get reduced? Because he's greedy. Why did the hydrogen get oxidized? Because he is not greedy.
Okay.
Right. Everything falls to that explanation sooner or later.
So if you're greedy, you get caught.
You're greedy, you get other people's electron in the supposedly sharing relationship. It's supposed to be sharing, but it's not.
I see.
When you're not greedy and you meet somebody greedy, well, the reverse happens. You get oxidized, meaning you lose your electron practically. It's just 1%, something like that.
Yes.
That's what the state means. And then you understand it from there, and then you start to do questions from there. Okay?
Yeah.
Okay. Along all the explanation of this topic, we'll continue to talk about greediness and not greediness. Now, I have to explain what I want Kyoko to do first. Now, Ainesh, have you finished your eating?
Yeah.
Right. Why don't you go back to finding your question in math first? Okay. Find your question in math, and then we'll talk about it, and then we'll come back to chemistry. Right?
Okay.
Right. Kyoko, sorry, I didn't have the participant on. That's why I didn't see you. Yeah, apologies. Again, can you hear me?
Yeah.
Yeah. Okay, you're also quite clear, right? Okay. So, how busy are you this month, Kyoko? November.
Quite busy.
Okay. Tell me a little bit. What kind of busyness?
I have school camps to plan for.
Oh, goodness me.
Yeah.
The orientation starts now. Really?
Yeah, it started already.
Oh, dear. Now I understand what you're. Okay, you're quite busy and you have to devote a lot of time in planning. The camp will start when?
9, 10. It's not an overnight camp.
It's a
full day
week.
camp. Yeah.
Full day, is it?
2 full days and 4 full days. It's 2 separate camps. 2 separate camps.
2 separate camps. Wow.
Yeah.
Okay. Those camps are going to happen when?
9, 10, and 17, 18, and 19.
Goodness me. That's next week. And then something like the week after. Right? So you're in a very busy stage. We didn't have tuition for 1 month, right? Were you already busy that month?
Yeah.
Okay, because at least we didn't miss much. Like, should have gotten tuition there if you weren't busy, right? Okay, I understand. Okay, I'm gonna tell you this. So I read roughly your work, right? I read roughly your exam. So I feel that certain things are good and certain things a bit sayang. I just told you roughly. Right. So wow, but what's the best thing? I want you to recover from your end of year by simply you don't have to be perfect about it, but I want you to surpass it. And that's I want your holiday, no matter how busy, to start like that. Okay, so that you know that you can. I think this is important. Right? Especially when you're busy and tired, you need to know that. I think we can make it happen very quickly. I'm not suggesting that we wait for the next exam. No. We're gonna start very soon. So, for example, do you have your own Sec 3 paper that you haven't used? If not, we'll open one from us, from mine.
No, not really.
Okay. Right. So we're gonna focus on trigo, right? Trigo, circle CG, trigo circle CG binomial, and your logarithm was okay, I believe. Was it?
Yeah, should be okay.
Right now, rusty or real?
I think if I look at the formula again, I and practice a bit, then I'll remember.
Just a little bit is fine. Right? So I'm just looking for topics that you were already strong. You were strong. You were strong already, right? So not talking about the ones that you are a bit unsure, right? So just by these few topics, I believe you can already surpass the result you have in prelim, right? Just by focusing a bit on that, right? So that's our goal. Now, if we go to so Ainesh, are you looking at your paper? Because I'm not seeing the math questions in the Jamboard.
Yeah, I still haven't found any.
Every paper should have, yeah?
Yeah, I'm looking through paper 1 right now.
Yeah.
Only logarithm, right?
Logarithm and indice lah. One package lah. The word problem one, the long reading one that we did, that's the package also, right? So we're finding very similar questions to the past 2 days lah.
Okay, I did find one.
Good. Put it in.
Sorry, can I take something first?
Yes, please. Sec 3. Okay. Oh, Ainesh, that's not. Oh, yeah. Okay. So, you have binomial. Oh, yes, you have binomial. So, Ainesh, this is surprise. It looks like in this. Yes, it is. It needs to use in this. This is binomial, and you haven't learned it.
Oh,
this is the big brother version of in this lah. So you don't touch this lah. But you remember what I mean by binomial. It looks kind of like this, very roughly. So maybe next time, if you're not sure, you can check with me lah. Is this supposed to be that? Then I can tell you lah. So in this case, this is not. This is not in this and logarithm. Right? You don't know how to do this yet.
okay.
Sorry, I'm back.
Yes, Kyoko. Right, I did share with you the Sec3 A Math drive, right? So would you please open that? Right. Let's choose one of the SA2. You just make a random choice. It's fine. You tell me which one.
Zhonghua Secondary,
Zhonghua, which year is that?
2018.
28. Hey, there's a 2018 question. Hey, are you talking about Sec3 A Math? Really?
Yeah. Oh no, sorry. This.
Yeah, don't go to Sec4. It's still confusing for me. Go to Sec3 one. I think I share, right? So let me check.
Yeah.
Yeah. Go to Sec3. Yeah.
Clementi Town.
Okay. Is the SA1? Sorry, Clementi Town 2016, is it?
Yeah.
Okay. Just check first that the answer key is there. I think it's usually down. Yeah, it's a short one, but it's okay. Right now, only one paper, right? Only one paper. Yeah. Okay. So your first task is very simple. Nothing to do with doing. You're just collecting the questions, right? So you're going to collect binomial, CG, circle, and binomial, CG, circle, and what do you call it? Trigo lah. The trigo that you can do by right lah. The trigo that by right you can do. If you see any other question that you want to, you can seem to do, feel free to collect that. But we are currently choosing questions. Okay, so Kyoko, screenshot the question that you choose, put it in the Jamboard, and then let me see lah. Right, Ainesh is currently doing the same thing. Okay, right.
They signed me out.
So Ainesh, what's going on?
You know how sometimes they kick you out of the Jamboard, right? And your recent edits get removed. All my pictures are gone.
Oh, goodness me. It's very rare, but it does happen. Yes. But I haven't had that problem for a long time. But it does happen sometimes.
I don't know how that happened.
Right. Okay. Don't worry. Please, a bit of frustration, a bit of setback. Please repeat that.
Yeah. Fun.
Should be faster since you know which one.
Yeah.
Right. Kyoko, okay, yeah? So you can put it in the yesterday's Jamboard. That's fine, right? You don't have to save space. You can separate them into pages. Yes, first fine, Ainesh, I agree. This is definitely what you're looking for, right?
How many questions are we looking at?
Oh, we're looking at every question that contains this topic lah.
Okay.
Don't know which one, don't know how many depending on the paper, right? So when you think it has run out, you tell me which paper. I'll do a first check. I'll do a double check. Right. So this one, the question 10, there is logarithm, agree. And you see this f dot thingy, f dot x thingy. That is secondary 4, so you cannot do this also.
F dot x. I don't see it. Oh, it is.
The pi, yeah. That's called a differentiation, and you cannot do this yet.
Oh.
So also not. So,
well, I was looking at year 4 papers, but
totally understand. That's why you're seeing all those topics lah. That's okay. But there will still be Sec3 stuff that you could do.
Yeah, okay, I stopped. The rest are all graphs, which I don't want to do yet. Unless you want to do graphs, and that's fine. That's
okay,
that's
that's really only one. You only found one, really.
Yeah, that is year 3.
Okay, let me see. Sorry.
Year 4, 2018 papers.
Sorry, 2018, right?
2018.
Yeah. Let me open that. Yeah. Okay. 2018. You have looked at paper 1 and paper 2, right?
Okay. Yeah, look at paper 2 first.
Oh, this one give you the answer key directly. Sorry.
Yeah.
So we don't look at the answer key. Okay, I'll look at paper 1 quickly.
I did find one paper 1.
Yeah. Oh, wait. Paper 1 obviously is 1 in the package. Come on.
Yeah, I put it in. You can see the gem code.
Let me see. Well, that is actually not part of the topic, but I don't mind you doing this lah. I don't mind. But 2018 paper 1, I'm looking at a very clear log question. Am I? Oh yeah, that's question 2 lah. Yeah, that's fine. I don't mind you doing question 2. I don't mind at all. It's not part of the package, but nobody says that you cannot. But look below, because they are very clear packages of indices and log. Very clear.
Oh, what is this? I did not see this.
Right? Very clear. Come on.
Yeah, I saw
Okay.
that. Is it?
No, that's partial fraction. That's polynomial. What are you doing?
Oh, sorry. Wait, is 7i? Does it relate to 7i?
I don't think so. Yeah, so you can skip 7i lah. Yeah, you can skip 7i. Look.
That's the reason I left it out.
But 7i is, so it turns out it's not connected. So it turns out
Yeah,
they are not making it that clear though. They don't make it clear.
Yeah,
So
because it's C-max.
don't blame you. Yeah, don't blame you. Don't blame you.
And
But 7i, and then there's still more. Very clear.
put in 8 as well.
Yep. So 7i and 8 lah. Right. So this is a lot of choices, and you accidentally choose beyond the package, which I don't mind at all. That's what we want to do.
What topic even is that?
It's not a complicated one. It's not a complicated one. But read lah. The important is to read lah, right? If you understand, then you can do it lah.
Okay.
Yeah, I'm just confirming that paper 2 we didn't leave anything. Yeah, we didn't leave anything behind. Okay, so how many total marks are here?
10 to 22.
So 22 marks means 22 minutes. Is that simple, right?
Okay.
This is the rate that you are going for because you already discuss and read it with me. If you don't discuss and read with me first, then you have more time. As you can tell with your 2 days before, you never lack time, right? That wasn't the problem. Right?
Yeah.
Right. So now we are doing the same thing. Hopefully tomorrow, I don't have to remind you again. You already know what you're supposed to do right now. You're supposed to read, discuss, target.
Okay.
Kyoko is doing the same, so I'm just waiting for both of you. Right? So Kyoko, tell me when you're done.
Yeah, some of the images I can't seem to upload.
Is it because Jamboard is taking it slow? Right. Okay, that seems to be a duplicate. Oh, what's going on here? Seems to be a duplicate. Okay, are you separate? How come I cannot wait? I cannot drag. Oh, I cannot do anything to your image. I'm not sure what's going on here.
Maybe I just delete the page.
Okay, try again. Yeah. Maybe you shouldn't stack pages lah. Maybe you just, one page, one question is fine. Right. So Ainesh and Kyoko, yeah, at this point, when you have a question, when you're reading, we just talk lah. Yeah, just talk and discuss. Right. Oh, you screenshot everything. No, that's not gonna work. You're gonna not have. So you want the cert lah. Is that what you're saying, Kyoko? You want the cert and you want the binomial, is it?
Yeah.
Right. So don't copy paste everything. Just screenshot that part. For example, here I'm gonna do it for you, right? Right. So I'm gonna do that for you. It's much easier for you, and then we're just gonna delete this big guy, right? Did I get the right thing? Okay, so do that. Okay. You're just selecting question. You don't care about the rest. How is it, Ainesh? That weird question, 5 mark.
I don't understand.
Why don't we skip that for now? Totally fine. We still have 17. And the rest doesn't seem to be particularly easy also, right? So let's forget about question 2 first. Let's concentrate on the package of indices and log, right? If we have time, we'll talk about question 2. Okay, Kyoko, I'm seeing question, there's supposed to be another circle question, right? Clearly, right? Clearly, there's a circle question.
It's making
Yeah, clearly there's a circle question, right? They even say the 3-go question, right? The 3-go question.
Mm.
The 3-go question is there. Yeah, it seems to be like that. Maybe I'll do some refresh. Right, Anesh, when you read, you are totally allowed to, annotate and write stuff, right?
Okay.
Can you do 7 too? How many marks would you target? Anything you want to ask?
25. That is doable. I think that I should be able to get 5 for 5, the simultaneous one.
I feel so. You have nothing to discuss?
Don't think so.
All right, right.
It's difficult to visualize what I'll do. Like I can see my first 3 steps.
First 3 steps is fine. No, first 3 steps is very good. Sometimes I'm happy with the first 1 step. Really. You okay? Yeah. You okay, yeah. All right. Good.
For the 25 and the 16.
Good. Okay, that's fine. Right. And go on reading. Right.
Okay.
Okay. So yeah.
I really cannot upload anything.
Goodness me. All right. All right. So you tell me what you want. Right. So technical problem.
The CG question and
the CG question. So the CG mean the rhombus one, right?
Yeah.
Okay, the rhombus one. Then after that, what do you want?
The circle question.
Which is question 11. Okay, then.
And then the 3-go question.
Which is question? Which one?
The one that says like the angle is lesser than 270 but greater than 180.
Question 10. All right, then nothing else. There is one more 3-go question, and I think you can do it.
The graph.
Yeah. Clearly, the graph 3. Clearly.
Okay.
Right. Question 6. Right. So I'll try to put it in for you first. Oh my goodness, it is a struggle. Right. So here's 2 questions. And then let's do. Now, while I upload, you're going to total the marks, right? And then you're going to find out whether there is enough to surpass your, you get a Z, right? To surpass your promo result, your end of year result. The topics that you have chosen is the super big mark topic. So it's high chance that you will potentially surpass, right?
Okay. Is there anything? Oh, I can't see anything.
Right. You mean the Jamboard is not uploading, really?
Yeah, I only see page 9 and 7.
Okay, never mind. You have the exam paper first, man. So for the totaling, you can just total first lah. From the I'm just preparing it. In that case, if you cannot do the Jamboard, you just do on paper lah, right? Whatever lah, technical problem, who cares, right? So what's the total mark here that we're dealing with from the questions that you chose? So Ainesh, you 4 to 5. You seem to be more and more confident with this kind of question.
I feel so. I don't know.
Right,
but this is a simple replacement.
This one, the first time they ask you to find K though, right? Just saying first time, be careful.
Wait, never mind. I take back my confidence.
Yeah, first time they ask you to find K, but this is the variation that we're looking for. They keep varying slightly, and you will achieve the completeness there lah. Right? Yeah. You should still try lah. Okay, let me just give you some warm up to make you happy, right? To make you happy. At the start, my favorite question, right? At the start, what's the amount of the health supplement at the start? Which is the question part 2, right? The initial amount of health supplement. Confused. Oh, you bloody nonsense! Come on.
9.
Oh, I know there's a variation here. Try again. 9 is better than 2, but try again. Why is it 9? T equals to 0, right?
Yeah.
So the y will be?
The y will become it's 11.
Yes, because the plus 2 is something new here.
Yeah.
Right? Don't let it take you by surprise, right? Okay.
Yeah.
So we cheat a bit. You were doing that. So whatever. I'll close my eye. Okay. Yeah, you go find the k, okay? Do your best lah. Now, logarithm. Okay, so what do you think, Kyoko? How many total marks are we dealing with here?
Like 43.
43 total marks if we get everything, yeah? Of course.
Yeah.
Now, how many, because you say your mark is 42, right? But is 42% 42 marks? Is that how it goes? Or is it, what is it?
Yes. Yes.
So are you sure the total is 100 back then?
Yeah.
So you're saying that it is possible for us to surpass that if we do all 43 correct lah. Okay. Maybe choose one more question, just to be safe. Maybe.
The logarithm one.
The one at the last one? This and log, is it?
Simultaneous. Yeah.
Only the simultaneous one.
The entire question.
Oh, yeah. You want 12 ABC.
Yeah.
Oh, okay. Okay, that's a lot. Okay. Good. That's additional 11 marks, right? Wow, that's a lot. Okay, so I guess we have a total of 54 marks to try, right? Right? Now, here's the few rule. You don't have to start doing this, okay, Kyoko? That's not what I mean. What I mean is we're going to do things just like how Ainesh is doing things. Ainesh is going to read his own question. You are going to read this question and discuss with me, especially the things that you don't understand. I am supposed to help you understand the question, but I'm not supposed to help you to do it. Let me repeat this. I'm going to read until you're very happy with all the questions. You can kind of imagine what you're going to do, but you cannot do it. You can write some notes about what you're going to do, but you cannot actually do it. This is called reading properly. You understand? So that's what you're going to do. Let's start reading today, and tomorrow, if we are meeting, just read again until you're happy with the reading. Then you start to do it. I'll tell you how to do it also, right? There's some restrictions. Understand, Kyoko?
Yeah.
Okay, so ask any questions, just like how Ainesh is doing. So Ainesh, how's the first log question?
I think I can get 3 out of 3.
The first one. Okay, good. I like the confidence. It looks okay. Right? Consult your laws and everything if you're not so sure. How about the second guy?
I'm not very confident of this.
Right. You're going to tell me where you're not confident.
There's different bases that automatically makes it a lot harder.
If you have different bases, I'm not telling you how to do it, right? If you have you just change base. Do you have, if you want to change base, you have to target a certain base. What base will you be targeting? You have to make that choice. What base?
5.
Okay, so the first guy is already base 5, right? So happy lah. The second guy, I think you can change it quite easily. I think you'll go somewhere there, right? Second guy. The third guy is on the right-hand side. That guy is also not base 5, but base 2. Should you change that guy or
not? Yes.
Yes, change all the way. Change everybody to be. I'm not saying that base 5 is correct, but at least you have a target. So at least your first few steps is reasonably clear. Where will that lead you? You'll see for yourself, look.
Okay, so I'll give it a 2.
Okay, write down on target. Hopefully you'll get more, right? Hopefully, always hope.
Yeah. When's the device arriving?
I'm sorry, what? Oh,
Oh,
yeah,
when's-
no, I'm supposed to send today, right? And then I didn't get your block. The other guy I'm supposed to send, I also don't have. So I'm going to send tomorrow. The
Okay.
device is ready. The device is ready. Right?
So arrive at tomorrow.
Yeah, I hope so. I mean, it's much easier than doing this with mouse. I'm looking forward to it. Right. Okay. So shall we forget question 2 for now? Yeah, let's just not do that for now. It's okay?
Yeah. Then we change the code to 5.
So instead of a 22, it's now 17, right?
Yeah.
So 17 marks, 17 minutes. Are you sure you have no other thing to discuss with me? Because that is your homework, right? For tomorrow morning.
Sure.
Okay.
Yeah, I don't have anything else.
Right. As per usual, I'm going to assign you a reading. Your reading speed is not very fast, but understandable. New topics, right? Could you please complete your oxidation and reduction reading?
Okay, sure.
What is the most important thing I teach you today regarding oxidation and reduction?
So greedy is better than non.
No. That's not what I teach you. No.
No?
If you're greedier than the other person, you will take their electron, right?
Oh.
They will actually be happy to do it. It's weird, lah. But if you're greedier, okay, you have my electron. No? If I'm greedier, I'll have your electron, and that is the source of reduction or oxidation. Now, think about this carefully. If I am greedier than you, is it possible if I get reduced and you don't get oxidized? Is it possible?
Yeah.
What are you talking about? Me
No.
getting reduced means me basically owning your electron, right? Is it possible for me to own your original electron without you getting oxidized?
No.
Yeah, that's it. Look.
Okay.
If I'm getting your electron, I will be reduced. Is it possible for me to be greedy of your electron and not get reduced? I'm going to take your electron, but I don't want to get reduced. Is that possible?
No.
Yeah. That's why the best definition so far is losing and gaining electron. And that's why redox equation, the one that you asked, means like that. In a transaction like that, I take your electron, you lose your electron. It is clear that somebody must lose and somebody must gain one. It's very clear. So somebody must reduce, somebody must oxidize. One more time. Is it possible for somebody to be reduced and nobody be oxidized? Is it possible?
No.
Let me say it another way. Is it possible for somebody to be oxidized, but nobody is getting reduced?
No.
Therefore, you already understand the essence of redox. You just have to read and do the questions to gain experience. That's all. Right? That's all. I really want you to read until the end.
Okay.
Right? Because I think the end is getting to where I'm telling you. Okay. So your two homeworks will be the math, do it in the morning slot, shift a little bit, and then read, finish the redox. I'll see you tomorrow.
Yeah.
All right. Okay.
Bye. Have a good night.
You too. Now, Kyoko, I'm not hearing any question from you yet. Right? So which one are you reading right now?
10B and C, I don't really get it.
Oh, you already read 2, 3, 5, 6, everything. Really?
Yeah.
And you have no problem with 2, 3, 5, 6, really?
Oh, sorry. It's number 6, question 4.
Okay. Let's talk about question number 6.
Never mind. Sorry. Question 10.
Oh, you can, your 6 also, okay, no problem.
Yeah.
You don't seem to be very rusty, right? You don't seem to be very rusty. Okay, so question 10, part C, is it?
Yeah.
Okay,
Part
so
B.
Okay, so I'm sorry, what's your, okay, I just want to tell you that the 10B doesn't seem to be connected to 10A. Likewise, 10C doesn't seem to be connected to. pen B lah. I think and here lah. Not always the case, but I think so lah. Yeah, right. So what's your problem?
I don't really understand what equation is.
Okay, now let me tell you something. It seems that for your school, this you just learn. This is the multiple answer one. So for part B, they ask you to solve, they want you to find X, and they're expecting more than one answer from you. Now, if you don't understand this, then you shouldn't do this question because that's not your end of year, and we haven't talked about this too much. But if you feel like you want to try, nobody's stopping you.
I don't think I should try.
Right. So pretend that you're not trying this. So I'll give you more hints lah, because then I'm free to tell you what to do, right?
Yeah.
Okay, so they mean find X, ma. The X is inside the sign. The sign is inside a square, correct? I mean, is it that hard to, just make the subject? Not that hard, right? The equation doesn't look very complicated. I mean, first thing first, you're going to move 8 to the right, correct? And then you're going to do something to the quadratic, correct?
Yeah.
And then you're going to do something to the sign to free the X, correct? Then you are like slightly more than halfway already. The question is whether you can get multiple answers from that or just one answer. Okay, now isn't that what you learned, recently in class?
Yeah.
Okay, so I'll leave it to you whether you want to do it or not. Okay, that's okay. Right? The rest, please do lah. How about part C? Part C, same thing one. Part C is just radian, not degree. Same thing with part B1. Just make Y the subject.
Okay.
All right. So 1 degree, one same technique, same concerns lah. Okay. Right. If you are okay, if you don't want to ask anything else, go to the next 2 questions.
Second problem, simultaneous equation. I don't really know how to start.
Right. So does your teacher give you does your teacher give you how to practice this on simultaneous or not? This kind of simultaneous?
No.
Right. So this sometimes happen in exam lah, only sometimes, right? So I suppose if you want to practice this, it's good for your general logarithm in this skill lah. So I guess that's something still, right? Okay. So now look at the simultaneous equation. Obviously, you have 2 unknown. Obvious, right? Obviously, this is not your standard X and Y, right? Now, what you need to do for the first equation is very simple, right? You're going to do what you do normally in this question. If you see in this question like this, your instinct should be to do what? To make the what?
Make the base the same.
Do you have any target base to make the same?
No.
What do you mean? There's 27 power x. There is 9y root, and then there's 3. Certainly, there's a base that we can, make everything the same.
3.
Why don't you give it a try? Now, once you make all the bases the same, the benefit is you simplify things. That's the usual benefit, right? Or that's why you want to make the base the same. If you don't make the base the same, nothing can happen. If you make the base the same, you can simplify things. Once you simplify things, I think you'll get a better, nicer XY equation. That's the purpose lah. Okay. Now you're not supposed to do this, okay? So stop doing it. You're not supposed to do this. You do this on the time limit I tell you, right? But you have the idea, you understand? You have the idea, right? So erase that first. But I now you know that you have a good idea, right? So erase that first. Erase. Now the logarithm follows not a very different path. The base of the log. So in this, the base of the index, log the base of the log. If the base of the log are usually different, you want to make them the same. In this case, are they the same or are they different?
The second one.
Yeah, the second equation.
The same.
If they're the same, then tendency-wise, you don't have to do too much at the start, because the base is already the same. You can simplify. That's the motivation. So you try that first. Now, in both cases, the first equation, second equation, if you do things right, something like that, the equation simplifies. Once it simplifies, you can solve it simultaneously. Before that, you can't. Right? So it's not that complicated. You just have to simplify before solving it. Okay? Feeling better? Okay, check one more time. Any question on
The 12B.
12B. So what's your concern?
I can type it in the calculator, right?
Yes, but typing in the calculator is not going to help you solve here.
Mm.
But you can type it for confirmation. I think for confirmation, you can. Now, let me give you some hints, okay? Again, maybe you're last. I think I told you last time, very shortly, in this, we don't touch much, right? Very shortly, that if indices have a plus minus below, look at that, 2e power x minus 1. That minus is what I'm talking about, the minus below. When indices have minuses or pluses below, it's almost always certainly a lab question.
What, sorry?
Lab. Something, 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 be something, something, something.
I'm not sure what you're saying.
Substitution. Substitute this in this to something else? No? No idea?
I think if you write it out, understand better.
I am limited in how I can tell you right now. Right? After you do it, then I can, right? So I'm going to look at example from your exam. Maybe your exam have. Right? Again, I'm limited in how I can help you right now, right? Because this is before you do it. Oh, goodness me. That's why your question 1 is wrong in your... Oh, goodness me, Kyoko. You're in this. Look at question 1, page 1. Okay. Now, look at this positive and this negative. What did I say? If in this question, there's a positive, negative below, it's almost certainly a lab question, right? So I'm going to demonstrate that to you here. See whether you can apply it there. Okay.
Okay.
Immediately, I'm going to declare this, that 2x equals to y. Have you ever seen this before?
No.
Oh, goodness me. Right. Okay. So I'm not sure what's happening in the class, but not surprised. So stick with 2x first plus this is going to be 2 to the power 4 over 2 times 2x, correct? Minus 2x over 2 to the power 2, right? Correct? What am I doing? I'm targeting this guy. I'm targeting it because why? At the start, I say, if in this question has plus or minus below, it is almost certainly a lab question, so I'm going to try that first. Lab means substitute 2 to the power of x. In this case, that's my target. I decided on that target equals to y. Y plus 3, right? 8y minus 1 over 4 y. Correct? Which is going to be a very simple y, right? So tell me what it is.
8 quarter y.
I'm sorry? 8 1/4, yeah. 8 1/4 y. Sorry. Did I see it correctly?
8 3/4 y.
8 3/4, I'm so sorry, what am I talking about? Which is 35 over 4y. You cannot see. Now, this question is more difficult than the usual one. I don't know why they give you 3 marks. Because you have to think carefully. What does this mean? This is exactly divisible by 5. Why is that so lah? Right? Why is that so lah? Right. So I'm not sure where this question is heading, but I'm just asking you to focus on this thing. The last part is the uniqueness of this question. He wants you to prove the divisibility by 5. Let's not talk about that first. Let's just focus on the technique above here, the lab technique. You have never seen this in your practices in class. Terrible.
I think they do like the 2x equals u.
2x u lah. That's fine. Anything you want. Now, my point is this is a major technique. And I just told you when it is likely to apply.
Yes.
You understand?
Yeah.
This is as far as I can help you for the exam question. Okay? I cannot help you there. I can help you here. Fair? Yeah? Okay. Now, back to the questions. Are you sure our reading, our understanding of the question is good enough for you to try?
I'm not confident in doing the question, but I understand what the question is trying to say.
Now, our goal is to surpass end of year. So it's a mental and moral goal. You understand? Here's the limitation. Again, I told you, you can read as long as you want. If you don't want to do it yet, you can ask questions again next time you meet, right? You can look at what you have learned. What you cannot do is this. What you can do is you cannot do the question, right? Before the minutes start, there's a time limit because exam, right? You cannot look at this question and another similar question side by side. If you want, you just look at other questions that seem similar, but don't compare side by side like that. Right? So either look at this question or look at the other things that you have learned. Don't put side by side. Understand? Again, in the process of reading, you can take notes, but just don't do. After a while, you understand what it means. This is just your first time doing it. Don't worry. Another limitation is usually in every exam, it's 1 mark, 1.5 minutes, right? Usually. Right now here, I'm giving you a limitation, right? Because we go and read and discuss and prepare ourselves, so to speak, right? We have prepared ourselves very well for this question as much as we can. You only have 50 marks, right? You only have 54 minutes to do this. And your goal is to surpass 42. So you have 54 minutes to gain more than 42. That is our goal. I propose that's how we start this holiday, even though you're busy. Do you think you can do this?
Yeah. I think I'm okay.
Right. Again, you understand the purpose of doing this, eh? Right. To get your confidence back.
Yeah.
All right. So whenever you start low. Just don't break the 54 minutes. It's only 54 minutes. Just time 54 and then just do low. Right? If you can confirm, you confirm. Your speed is usually fast one. So you will probably have time to confirm. Because in the end, what you want is to surpass 42. I'm not asking you to get 54. You understand?
Mm.
I'm saying to get 43, let's say. If you get 43 in 54 minutes, aren't you much better than your promo? Your end of year.
I guess.
Because in your promo, you get 42 in a much longer time. How many hours was it?
1 hour, 2 hours, 30 minutes.
Correct. My goodness, this is not even half of that time.
Yeah.
Right. So the time matters. Yeah? I'm not joking when I say 54 marks, 4 minutes. It really tests you to be serious, man. But it also tells you, I mean, getting 43 marks in 54 minutes is really something, no? And we can therefore put our end of year behind us. It's okay. Right? Then we'll continue to improve from there.
Yeah.
Of course, if you don't hit it this first time, we'll try to hit it the second time. Of course. Right. Okay. Are you clear about all the restrictions and the goal?
Yeah.
Then you try to do that. Okay.
So like whenever I ready, I just start doing like
Just do
immediately.
that. Just time 54 minutes and then just do. I think you should do on paper lah. Don't do on Jamboard. I think a bit slower lah. I think better do on paper lah. Right. Okay. I mean, other than that, nothing else lah. Of course, mark yourself. After you do mark yourself, then you know your goals, and then I hope the next time we meet, you already have the marking lah. Whether you surpass or no surpass, you know. Okay.
Yeah.
So let's assume that we meet on. Let me see. Your camp is on 9, right?
Yeah.
So I would say that this Sunday you're still okay. Maybe we'll just meet this Sunday, and maybe I understand that your week cannot, but at least meet this Sunday. If you haven't surpassed, we'll do it second time. Choose question, read again, analyze again, then you do again.
Okay.
And then you're free to run your camp, and then we'll meet the next Sunday again.
Yeah, but I actually think like it's okay lah. It's not that much for me to handle. I'm
Are you
okay. Yeah.
Are you sure? You can meet Sunday and then next Tuesday again, really? The Tuesday is the day before the camp. Right?
Like, no, I can.
Okay, fine. My point is, we take it one day at a time. Next Sunday, I want to see you already do this first lah. Already mark first lah. Whether you surpass or not, talk about it. Okay?
Yeah.
Okay. All right, then. Can you? Good, yeah?
It's just that I'm like a very, how to say, I like to do things kind of person. Yeah.
You're a task-oriented person.
Yeah.
You cannot leave if you're not busy.
Yeah.
I'll make you very busy. Are you sure you won't regret this?
No.
You're already busy, you see. When people ask you to do things, you cannot say no.
Yeah.
Yeah. Okay lah. So do this one lah. I'm okay.
No, this one is okay lah. It's okay.
Yeah. Just surpass this lah. Surpass this. Tell me the update when you have done it, right? If you really, really, really want it badly and you didn't manage to surpass the first time, let's say you haven't, right? You know what to do, right? Take another paper, select the question, read again, total the marks. You have your minute, whack again, right? That's what you do lah. That's what you do to surpass, to put your disappointing result behind you, so that it doesn't haunt you lah, so to speak. Okay.
Okay.
Right. Anyway, I would prefer that you can do it the first time. Right. So I'll see you on Sunday.
Okay. Bye-bye.
Right. Bye-bye.